Why agricultural foreign trade is important? There have been times, although you have money, but you couldn't find goods. On the other hand, you have product, you produce enough, but you can't sell. There is no need to go away. Only the Ukraine and Russia war, we understand everything very clearly. Ukraine has enough product, but they can't sell. Some countries have money, but they can't buy any product. Agriculture is a very strategic sector, you know. There is no chance. You have to produce or you have to import. If you don't have clothes, you can leave. If you don't have house, you can leave. If you don't have shoes, you can't leave. But if anyone don't have food, they can't leave. So that food is very strategic and very important. So we have to focus on food production, agricultural products production, and we have to go on producing them all the time. I want to ask two questions, two easy questions. If Ukraine was not an important agricultural producer, do you think that the West countries, America, European countries, the others, will help Ukraine? My idea, don't. Another question, if Russia was not an imperial country, do you think that, again, the same question, do you think that the West should provide money, weapons, etc.? So we have to remember that all the time we have to go on producing the agricultural products. Martin and Schumann, they are American writers. In 1997, they said that, very critical sentence, they said that now, in 1997, and in the 21st century, the most important power in all over the world will be wheat. And while grain corridor, you know, tahıl koridoru Türkçesinde söyleyeyim, the grain corridor, all the people in all over the world learn the importance of wheat. The prices are going up and coming down. There is no sustainability. So, all the agricultural products are very important. In order to maintain the life, all countries have two main necessities. One, everyone wants to be safe in economic base and in army base. So, economic prosperity is very important. Most of the Balkan countries are the member of or candidate members of European Union. They turn their face to European Union. And for the military security, Balkan countries turn their faces to NATO. The key of the trade is security. Otherwise, the illegality will start. In that table, you can see the Balkan countries, which of them are the members of NATO, which of them are the members of European Union, and which of them are candidate full member, which of them are candidate member, and two of them are potential members. In the table, you can see that 9 countries of 12 Balkan countries are the members of NATO, and 5 of them are full member of European Union, 5 of them are candidate members, and 2 are potential members. The Bosnia, Herzegovina, and Kosovo are the potential members. The issues that affects the foreign trades. What's affecting the foreign trades? Political and economic factors, custom duties, trade barriers, logistical challenges, workable prices and local costs, infrastructure shortcomings, and different standards and regulations are affecting the foreign trades, especially the agricultural foreign trades between the countries. The table is very confused. Just an example. You know, the importation and exportation foreign trade codes are starting from 1 to 24. The agricultural products codes are from 1 to 24. In that table, you can see separately from 2000, from the year 2000 up to last year, the end of last year, which year Turkey, how much Turkey imports goods from 11 Balkan countries, and how much exportation was done from Turkey to 11 Balkan countries. These tables are a bit clearer than before. The exportation ratio of total 24 and the first three items. In 2010, exportation is 66 or more or less 67%. The other years, 42 and 51, it changed. When we check the table, we see that in 2022, Turkey's exportation is more than $1 billion to 11 Balkan countries, and the first three items are almost half of it. And this one is the importation. Before it was exportation, now it is the table of importation. In 2000, which one, is it the pointer? Yes. In 2015, the maximum level was in 2015. Turkey's importation from 11 Balkan countries are almost $700 million, and importation was $474 million. In that table, we see both of them, export and import, in the same table. As I told you before, in 2022, our exportation was more than $1 billion, and in 2015, our importation was more than $700 million, sorry. The first three, now we have to answer the question, what are the first three items? What does Turkey import from 11 Balkan countries? First item is export, our exportation, Turkey's exportation to total 11 Balkan countries. Edible vegetables, second, edible fruits, and third, products of vegetables. And importation from 11 Balkan countries to Turkey is first grains, second oilseeds and oil meals, oil byproducts, and the third one is agro-industrial byproducts. I think almost all of you know the empty glass and full glass example. That example shows our optimistic or pessimistic point of view. The same, let me show a light. This is full. And if we drink half of it and ask a question, is it full? If you say yes, true. If I ask again, is it full? If you say no, is it again true? Then, which countries earn all the time? Which countries earn all the time? We have to look the positive sides, the full sides. We have to be optimistic. Otherwise, the well-developed countries organize everything and they sell whatever they produce, they product to other countries. Conclusion and recommendations. Turkey is a Balkan country, and Turkey is the biggest country in the Balkan area. On population base, more than 50% is living in Turkey. And on area base, again, more than 50% located in Turkey. So, Turkey can be the locomotive of Balkan area. Trade is one of the important factors to keep countries together. If you have economic relations, the other countries have to help you. I mean, if, for example, Germany is a strong country, is an economic power, if there will be any problem in Germany, you have to be sure that all the rich countries will try to help Germany because Germany is their market while buying or while selling. It is necessary to develop agricultural industrial trade between the Balkan countries. I told you some information, about trade between Balkan countries and Turkey. The three first products should be determined for each Balkan country. Before, as I mentioned, I gave the first three for all the Balkan countries. But we can calculate, we can search one by one. For example, what is Kosovo's first three? What is Montenegro's first three? What is Serbia's first three? Determining where, how, and which quantity, especially the basic agricultural raw materials, foodstuffs, feedstuffs, inputs, and outputs may be ready for training. Turkey and other Balkan members have to support each other in WTO, World Trade Organization negotiations. Because in World Trade Organization negotiations, the international trade rules are discussing. So Turkey and the Balkan countries have to support each other while the WTO negotiations are going on. The Balkan countries have to adapt to the new market realities. You know, the market realities change year by year. The internet, now, internet age, before other age, before other age. So we have to adapt ourselves to the new market realities. Balkan countries' storage capacity is insufficient, and Turkey has enough experience on that area. So Turkey can help to Balkan countries while preparing their infrastructure, storage infrastructure. Some Balkan countries don't have sea connection, you know. So they and all the Balkan area have to focus on railway transport to support foreign trade, and sea transportation. Only from Bulgaria, the railway transportation is heavily going on. But for others, we can't say that. Rising of yield productivity will increase for foreign trade. We owe thanks to the seed researchers and producers, both agricultural seeds and animal semen. Seed means everything. Seed quality, if seed semen quality is not good, there will be no life in the future. Because although for the human beings, the seed semen is very important. For the animals, it's very important. For the agricultural products, it's very important. Realizing long-term arrangements in the light of dependency handicap in international trade. They are the conclusions and recommendations about agricultural trade between Balkan countries and Turkey. What to do? Getting the responsibility of living the agricultural areas in good conditions to the next generation. Because we bought the future from the generations, next generations. Good and sustainable foreign trade is the key lasting friendships. Efforts for the regional cooperation and to get initiatives. Positive steps necessity for the solutions of the problems. You know, time to time, especially the foreign ministers come together, negotiate the problems between the countries. If you sit on the table, on the stair, with a negative idea, there will be no chance that you will be happy or you will earn, you will win. It's impossible. So we have to get positive steps. Long-term regional trade agreements. You know, countries sign agreements for 10 years, for 5 years, for 20 years. If it is signed for long term, and especially the critical area, the Balkan area, you know, in the very near future, near past, there was wars, there was conflicts, many problems. So that area must arrange good relations between each other. Establishment of free trade zone. Free trade zone means, you know, trade on that area is free of duty, no tax. So we have to establish a free trade zone between Balkan countries and Turkey. Developing the logistic and storing infrastructure. If you don't have good logistic infrastructure, logistic facilities, you can't transport. Now, I am interested in foreign trade. For many months, we don't have any importation from Ukraine because it is difficult to find sheep, it is difficult to find trucks, it is difficult to transport it. If you don't have logistic facility, you don't have shipping facilities, it means that you can sell, you can transport the good that you paid your money. So again, I want to mention that sentence once again. We have to develop the logistic and storing infrastructure. And various agreements. Agreements, if countries prepare the agreements very clearly And honestly, it will live for a long time. So we have to sign, we have to prepare various agreements. That's all. Hoping a healthy, wealthy, and happy Balkans. Best wishes. Thank you very much.
We have different subjects today. So I will have the questions and comments just following the speaker. If there is any comments or questions. I have a question. So you are talking about the free trade zone between the Balkan countries.
Yes.
It seems to me very difficult because the EU tries to get everything under the EU, even they are member or not member. How do you manage it?
I'll show you in the... Very good question. Thank you, Mr. Chairman. In that table, now there's NATO, and nine of the Balkan countries are the member of NATO. But beside NATO, if there is any problem, for example, Turkey, I don't want to say Turkey, you know, our official name was changed. Instead of Turkey, after that in all over the world, we start to say Turkey. Because of that reason, I say Turkey. But Turkey can help Bosnia-Herzegovina, or Romania help Kosovo, etc. This idea is same to me, is same for the European Union. Although we are the candidate members of European Union, the Balkan countries, 5 of the Balkan countries are the full member of European Union, but we can organize, there is no restriction. We can organize. But one say is, your question is important from that angle. How much, what quantity can be imported or exported on that free zone? We'll try and see it. I agree with you. It is not too much easy, but it's not too much easy. But we can organize, we can try. There are many samples. Most of the countries, some of the countries are the members of European Union, but they have bilateral agreements. It's possible. Is it enough? Yeah, yeah. Thank you.
Okay, thank you very much, Yavuz. And thank you. And our next speaker will be here, Professor Abid Farid. Is he here? Okay, he's not here. And the next speaker will be the Abdul Qayyum. He was here in the morning. Oh yeah, here. Okay. And he will talk about nano farming. And he thinks this is a very promising approach. And I really wonder how will it be the nano farming. Would you like to use that?
Good afternoon, ladies and gentlemen. I'm Dr. Abdul Qayyum, working as Associate Professor, University of Haripur, Pakistan. Okay, today I will discuss about the nano farming, a promising approach for sustainable crop production and food security. Here are some of the applications of the nano agriculture. Nano foods, nano pesticides, nano nutrients, nano barcodes, nano fertilizers, nano fungicides, nano sensors, and the nano herbicides. Current challenges to the agriculture sector, the population of the world is increasing day by day. And whereas, on the other hand, the land area that is shrinking and the water sources, they are also reducing day by day due to the burgeoning population. And the global warming that has increased probability led to the physical stresses. And to meet the basic requirements of the food, we have to use the agrochemicals, which directly or indirectly threatens to human health and the environment. Challenges are producing more food and quality food in resource sustainable and environment friendly manner. Target oriented, cheaper and efficiently technologies, we have to use such kind of technologies for increasing the quality and the quantity of the food. And nanotechnology has the potential to boost the agricultural production to fulfill food, feed, and fiber requirements of the human beings. Nanoparticles can enhance the crop yield in environmentally friendly manner. The nanoparticles, they can enhance the crop yield by the application of the crop improvement. We can make changes in the genetic makeup of the crop plants. By the use of the nanofertilizers, we can improve the growth of the crop plants. And by the use of the nanomaterials, we can enhance the soil properties. And we can improve the stress tolerance in the crop plants by the application of the nanoparticles. We can enhance the drought stress, salt stress, and the UV stress in crop plants. And by the use of the precision agriculture, we can increase the productivity of the crop plants too. And by the use of the nanopesticides, we can cope up with the crop protection measures. The beneficial uses of the nanoparticles in the agriculture sector are nanoparticles. They can have a favorable effect on the germination, growth, physiological attributes, water and the fertilizer use efficiency. They have some of the positive impacts on the root growth, branching, biomass, and the photosynthetic pigmentation in the crop plants. Nanoparticles, they can enhance the nutrient use efficiency, photosynthetic use efficiency, grain quality, and grain quantity or the yield. Nanoparticles, they can enhance the photosynthetic activity and the nitrogen metabolism in the crop plants. They can improve the leaf area, improve growth, nitrate reductase activity, pod dry weight, and the grain weight in case of the soybean plants, and in grains, especially in case of the weeds. Increased hill reaction and the chloroplast and activity of the rubisco carboxylase several times. Nanoparticles, they can enhance the antioxidant activity in the plants. We needed to explore the comprehensive application profile of the nanoparticles to analyze research in crop science and ensure food security for the increasing crop productivity. Nanotech-based orientation of the agriculture can boost the production of the crop plants and more sustainable future of the agriculture sector. Where I'm working, our research team that is working on the metal nanoparticles. And the objective is to explore the role of the metal nanoparticles for improving the growth and enhanced yield of the crop plants. And mainly we are focusing with the wheat crop. Synthesis and characterization of the nanoparticles. We usually prepare the, in our laboratory, we usually prepare in fact, previously we have started this work almost 8-9 years ago. And the metal nanoparticles we were preparing by the chemical or the organic reduction methods. Some of the, in fact, we have two groups. One is the one group in which I am working. That is the biological scientist, where we are working with the crop plants, and the other one is the there is another group of chemistry department which is dealing with the synthesis and the characterization component. So we two groups both together working under one umbrella. So first one is the pictorial representation of the silver nanoparticles, copper nanoparticles, the iron nanoparticles, and the zinc nanoparticles. And the size of the nanoparticles was estimated with the X-ray diffraction method, scanning electron microscope, transmission, FTIR, and the zeta analysis. And the size of the nanoparticles was in the range of, in case of the silver nanoparticles, the range is fall in the category of 11 to 22 nanometer. Whereas in case of the copper nanoparticles, the size of the nanoparticles falls in the category of the 12 to 26 nanometers. And in case of the iron, the size is 20 to 30 nanometers in size. And in case of the zinc, their size is around about between 8 to 30 nanometers. Silver nanoparticles and wheat growth. Here you can see in the picture. Okay. Is this working now? Okay. When silver nanoparticles, they were applied at the range of 25 ppm and 50 ppm, the number of seminal roots in case of wheat plant, they starts increasing, whereas at 75 ppm and beyond that, the number of seminal roots starts decreasing. In fact, at the at lower concentration, they have the positive effects, whereas when we are using the nanoparticles at the high concentration, then they have then these nanoparticles, they have the harmful effect on the crop plant, and especially in case of the seminal roots in case of wheat. Silver nanoparticles have no favorable effect on the germination. Most of our results suggest that the silver nanoparticles, they don't have any positive impact on the germination of the wheat crop. The concentration of silver nanoparticles above 75 ppm, they have negatively affected the germination. The germination is being retarded when the concentration is increased. Silver nanoparticles significantly increase the number of the seminal roots at 25 ppm and the 50 ppm. Here, you can see the fresh weight and the dry weight of the wheat seedlings. The results indicated, in fact, the experiment was lasted up to 4 to 5 weeks, but the results, they are presented from up to 1 to 3 weeks. The results indicates that the silver and these wheat seedlings, they were grown in the MS medium hydroponically. The results indicates that even when we increase the, in fact, when we apply the minimum concentration of the silver nanoparticles there, dry weight and the fresh weight of the plants, that starts increasing. So these silver nanoparticles, they don't have any positive impact on the seedling fresh and the dry weight. Effect of silver nanoparticles in the MS medium on the root biomass. Root biomass results indicates that at 25, when the silver nanoparticles, they were applied at 25 ppm, the results, they were much better as compared to the control and the other concentrations. So the root biomass is improved when we applied the silver nanoparticles at the rate of 25 ppm. These are some of the results of the relative crop growth rate and the net assimilation rate. All these concentration of silver nanoparticles, they don't have any positive impact on the crop plants. In fact, some of these, when we have start increasing the concentration of these nanoparticles, then relative crop growth and the net assimilation rate, they starts decreasing. Okay, these are the previously these results when we applied the silver nanoparticles in the MS medium. After that, we did some sort of experimentation on the crop plants when they were grown in the greenhouse. Effect of the soil applied. These are some of the results of the soil applied silver nanoparticles on plant fresh weight, dry weight, and the chlorophyll contents when the plants, they were grown in the pot conditions. And the results indicates that when silver nanoparticles, they were applied at the rate of 25 ppm, the fresh weight, dry weight, and the chlorophyll contents, they starts increasing, and higher concentration of these silver nanoparticles tends to decline these attributes. Here are some of the pictorial representation of these silver nanoparticles when they were applied under to the crop plants under greenhouse. Effect of the soil applied silver nanoparticles on yield attributes of the wheat crop. Yield attributes that contains the grains per spike, 100 grain weight, and the yields per plant, because the plants, they were grown in the pots under the greenhouse conditions. The results indicates that the silver nanoparticles, when they were applied at the concentration of 25 ppm and 50 ppm, the grains per spike, 100 grain weight, and the yield per plant, that starts increasing, but at the high concentration beyond 75, and even at 75, these yield attributes, they starts decreasing. These are some of the publications from our group. After this silver, we start working on the copper nanoparticles, and the crop remains the same. Wheat, one of the most important crop of the country. We are having a huge population, and that's why everyone is focusing towards the wheat instead of focusing towards any other crop. So that's why we are also working on the wheat crop. Majority of the groups in the country, they are working on the wheat crop. Okay, copper. The best response of the wheat seedlings to the application of the application of copper nanoparticles in this solution culture. We usually here also we did experimentation in the hydroponics, and the wheat plants, they were grown in the MS media. Under the controlled environment, we usually use various concentrations, and they are usually at low 0.2 ppm, 0.4, 6, and in this way it goes up to 1 ppm. Whereas the results, they were much promising at the concentration when they were applied 0.4 ppm. Here you can see in the pictures, when we compare the results with the control one, the shoot biomass and the root biomass, they are much better as compared to the control seedlings. Another example, this also indicates that the seedlings, they perform much better at 4% ppm as compared to the control plants. Another example, when the crop plants, they were grown under hydroponic conditions. Okay, we did some sort of experimentation when the plants, they were grown under the hydroponic, and after then we switched towards the greenhouse experimentation. During the greenhouse experimentation, we observed that the low concentration of the copper nanoparticles in the soil up to 10 ppm did not affect significantly. Even we started various concentrations, 2 ppm, 4, 6, 8, 10, and we did not find any kind of significant results. So after that, we did some sort of calibration, and we increased the concentration of these nanoparticles up to, I think so, 10, 50, 10, 20, 30, 40, and 50 ppm. And we found some sort of significant results there. And this picture indicates the growth of the wheat plants in response to the soil-applied copper nanoparticles that range from 10 ppm to 50 ppm. And we have observed that at 30 ppm, when the copper nanoparticles, they were applied to soil at the rate of 30 ppm, the plants, they responded much betterly as compared to the 20 and the as compared to 20 ppm and the 40 ppm. This picture indicates the picture, for a second, the third one. Here, it indicates that this crop, they were spread with the 30 ppm, and the results, they are much promising as compared to the other ones. The best response of the wheat plants is at 30 ppm. Growth of the wheat plant in response to the soil-applied copper nanoparticles. These are the results at the harvesting stage, just before the start of the harvesting. Copper nanoparticles and the wheat growth and the yield. Here, various attributes, they were measured, like the leaf area, the chlorophyll content, grains, per spike, spikes per pot, grain weight, and the yield. And the results indicate that all these attributes, the leaf area, majority of these attributes, the leaf area, chlorophyll content, spike, grains per spike, spike per pot, 1,000 grain weight, and yield per pot. They gave quite better results as compared to the at 30 ppm as compared to the other concentrations. So on the basis of these results, we can conclude that the silver nanoparticles at 25 ppm and copper nanoparticles at 35 ppm can enhance the growth and the yield of the crops. And the expected yield increase in the field, it is up to 25 to 30% basis on when we compare the results, our results with the other ones. These are the just expected yield increase, not the actual ones. After the copper, we switch towards the iron nanoparticles. This figure indicates the effect of the iron nanoparticles on the chlorophyll, leaf area, relative growth rate, and the net assimilation rate of the wheat plants grown in the grown under pot conditions. Here, the results indicates that in case of the iron, in case of the chlorophyll content, the results they were quite better at 30 ppm, whereas the leaf area, relative growth rate and the net assimilation rate, the performance of the crop plants that was much better even at 30 ppm when we applied the iron nanoparticles. And pictorial representation of the crop plants and their response to iron nanoparticles at 30 ppm. Effect of different concentration of iron nanoxide particles on the wheat. Here, results indicates that even at the 20 ppm, when we compare the results with the control one, they are quite much better. But the results at the 30 ppm, they were much more better, even at 40 ppm and 20 ppm, when we compare it with the control ones. But when we start increasing the concentration of the iron nanoparticles beyond 30 ppm, the yield of the crop plants that starts declining. Yield responses of wheat to the iron nanoparticles. The number of grains per spike, number of spikes per part, spike length, 100 grain weight. The crop plants, the wheat that responded quite positively when the crops they were when the when the iron nanoparticles they were applied at the rate of 30 ppm. In case of the zinc nanoparticles, similar kind of results like that of iron. The plants they responded quite positively when the zinc particles they were applied at the rate of 30 ppm. So on the basis of our results, we can include that this is especially in case of silver, 25 ppm, that is the quite best range, whereas in case of the zinc, iron, the plants they respondedly quite better when their concentration of the nanoparticles is at 30 ppm. Then is the effect of foliar application of metal nanoparticles on the wheat. Here in this experiment, in the previous experiments, we have applied all the nanoparticles one by one in different ratios or in the form of when they were applied solely. But here in this experimentation, we combine these nanoparticles, and when we combine these nanoparticles, we observed that when the silver, iron, copper, and zinc nanoparticles, when we combine together, the crops they respond in a much positive way as compared to the application of sole or individual, what we can say that, this one. Okay, here effect of different combination of nanoparticles on the yield attributes of wheat plants. Here we can also observe that when all these nutrients when all these nanoparticles they were applied, then the crops they responded much positively way as compared to the other combinations. In either the one, silver iron, silver copper, zinc iron, but when they were combined all together, then results they were quite better. Effect of different combinations of nanoparticles on the grain yield of the plants. Here we can see that the combination of silver, copper, and zinc oxide that was much better as compared to when we were applied iron 2. Metal nanoparticles can significantly increase chlorophyll content, leaf area, leaf fresh weight, dry weight, number of grains per spike, 100 grain weight, grain yield per pod. Based on the results of these experiment field trials were conducted with the objective to explore, with the objectives to develop a nanoparticle-based formulation for foliar supply for foliar spray to boost growth and the yield of the crop. After 12, I think so, the field trials, nano crop booster, we developed some sort of a foliar spray. For foliar spray was developed. Patent application for this formulation is in the progress phase. This formulation, when sprayed on the wheat at the start of the tillering, preferably or 20 days before the anthesis, will increase the yield of the crop plants. This can also be used on the other crops and the vegetables for positive results. Nanoparticles definitely have the potential for sustainable increase in crop yield in an environmentally friendly manner. We have to transform the chemical-based crop production to the nano-agrotech for sustainable crop production in a resource and environment-friendly manner. We need to blend the agriculture with the nanotechnology. Nano-agrotech a promising approach for the sustainable crop production. Thank you.
Is there any question or comment on application of nanoparticles on wheat? Now you applied these nanoparticles, and you said you had some field trials, right?
Yes.
Field trials. They're large field, or they are?
Oh
still
no, these are on the small scale, demonstration base.
The big farmer field.
Oh no, not on the farmer. No,
That's the experimental fields.
Yes, experimental fields.
So you get the 25% or 30% yield increase in wheat.
Yes, when we compare these results with the controlled ones or with the already reported ones.
So you got this 25-30% increase applying the one nanoparticle, like the copper nanoparticle or whatever, or you get this good result with the combination? Which one is the better?
In fact, when we apply with the combinations. Yes, here in this last slide, if you could.
I mean the field trials. I'm not asking about the ports. No ports in the field.
Oh, yes. Yes, when we apply in the fields, in case of the silver, copper, and the zinc, not with the iron ones.
Combination in the field.
Yes.
Okay. Is there any question? Yes, please.
Sorry?
In your experiments, I guess you didn't care about how much iron you have already in the soil, right? So if, for example, you spray these iron nanoparticles on a plant that is cultivating iron-rich soil, would you see any effect or not?
If I'm going to apply these nanoparticles, you are asking?
I'm asking if there is already a lot of iron in the root system, in the soil.
I have no idea about that one, but in Pakistan, the majority of the soils, they are the zinc and the iron deficient soils. And I think so, according to the reports of the FAO, when we are moving towards the zinc fortification or the iron fortification, that's why we are focusing towards the zinc and the iron one, so that we have to meet the deficiencies of these micronutrients, especially the zinc and the iron. But I have not experimentation on those soils which are already rich with the iron. In our country, we are having the soils, the zinc deficient and the iron deficient soils. I have no idea about that one.
Yes, please.
Thank you very much. It is a nice presentation. I'm also doing research on nanoparticle or microparticles from oil palm, and as a encapsulant for probiotic. But in this case, I want to know how do nanoparticles to increase the grain yield or crop production? I mean the mechanism, how the nanoparticle increase the yield or crop production?
I think that each physiological part of the plant growth affects your application, affects the chlorophyll A, B, but when I look at your results, I saw it the more you support the root part with this nanoparticles, which is the main point for the causing the yield increase. And I mean the chlorophyll A, chlorophyll E, or what are another physiological things. I think that he asked this. Am I correct?
You are asking about the physiological aspects.
The reason actually you apply the nanoparticles and you get the increase in the weight yield. So which mechanism nanoparticles affect to get this yield increase? Which mechanism in the weight? And
Sorry.
synthesis, or for example, you talked about Rubisco, former papers, there was effect on Rubisco or whatever.
Okay. About the physiology of the crop plants? Sorry.
You guys can talk outside
Okay.
again. Thank you. You can discuss with him the outside. Maybe it will be better. Is there any more question? Okay, thank you.
Thank you.
Our next speaker is the Ioannis Tokatlidis, and he's talking about the effect of climate change and the seed-producing crops. It's up to you. Would you like to use the microphone or use this one? This one. Okay. Yeah.
Bir saniye hocam.
Okay, or you can use it. Whatever you want.
Okay, good afternoon. Let me joke the first. About 9 years ago, I've been in a conference in USA, in California, the Crop Science Annual Meeting. In my speech in the room, there were about 15 people, and I started with the phrase, fortunately, I brought with me some colleagues, so there is a considerable audience in the room. Unfortunately, in this time, I have with me only my friend, my colleague, Rafael. Anyway, I thank very much Professor Kaya for the invitation. And I really appreciate this opportunity to present my experience in issues of agronomy and crop breeding. The title of my presentation, Breeding for Crop Spacing, is imperative to adapt seed-producing crops to climate change. But what does crop spacing mean? At the moment, most of the crops require very high plant population densities. We call them density-dependent crops. I'm going to show that it is urgent to find new varieties that could be planted at lower densities, of course, without compromising the productivity level. This is the meaning of crop spacing. 2 points for skepticism. We sometimes, breeders, confuse breeding, artificial selection, with natural selection. However, there are key differences. In the natural ecosystem, the target is survival under an allo-competition regime, while in the agroecosystem, in the crop environment, the target is the crop yield, productivity, under self-competition regime. Allo-competition means competition between plants of different genotypes, while self-competition between plants of the same genotype. Therefore, natural selection acts on competitive ability and the competitive genotypes of the competitive ideotype, while breeding should focus on resource use efficiency, seeking genotypes of the productive ideotype. Because of this confusion, most breeders use the plot intent stand as evaluation unit for the progeny line, assuming that they simulate the crop environment. However, in fact, the allo-competition regime prevails because any plant may represent a unique, a different genotype. Thus, in fact, plot, particularly in the first generations, highly heterogeneous first generations, simulates more the natural than the agroecosystem, and is the main cause of crop dependence on high densities. Breeding should emphasize on genotype yield efficiency, in other words, on plant yield efficiency, which I'm going to show that it is recognizable when plants are grown under very low densities. Besides a brief introduction and definition of plant yield efficiency, the outline involves major reasons for seeking genotypes of improved plant yield efficiency and the appropriate breeding method to succeed such a goal. Because of climate change, we deal with an enormously fluctuating environment, and biodiversity is responsible for different agroecosystems of a particular crop, the same field in different seasons or different fields, to vary in attainable crop yield greatly. To the worst, environmental diversity is responsible for a considerable yield gap, actual farming yield, lagging the attainable yield. The yield gap is of the hottest research issues nowadays among the scientific community, and several studies have looked at potential contributing factors, however, ignoring a major root source, which is plant yield efficiency. Because of lack of improved plant yield efficiency, most varieties can exploit favorable agroecosystems but are not adaptable to poor agroecosystems, resulting thus in yield gap, while others, which are appropriate for poor agroecosystems, cannot exploit favorable agroecosystems. We need new varieties of broad adaptability, exhibiting plasticity, and for such a goal, the improved plant yield efficiency and crop spacing are determinant. Plant yield efficiency is reflected by the ability of the single plant to produce grain at low densities. As distance between neighboring plants increases, the input share for each plant also increases. Thus, improved plant yield efficiency would imply individual plants that are highly responsive to additional inputs, increasing their grain yield. In other words, a genotype of high yielding capacity %. Crop yield, the ultimate goal, is the product of both the mean yield per plant and the number of finally established plants in the field. Breeding so far, serving the intensive agriculture, emphasized more the second parameter, tolerance to high densities, neglecting the single plant performance. And because of stagnant plant yield efficiency, most varieties exhibit normally high and usually erratic optimum density. This is a threat against sustainability. Improved plant yield efficiency would lower the threshold of optimum density, allowing crop spacing of prime importance in terms of stability. It is well known that the genotype, competitive and yielding ability are two distinct characteristics that are inversely associated. This means that, in fact, plant yield efficiency is tightly connected with the weak competitor ideotype. In other words, competitive and protective ideotypes are the two extreme types of genotypes. Key reasons bring to the fore the productive ideotype, which combines low competitive ability and high plant yield efficiency as a means of crop spacing. The first reason is the necessity to deal with the acquired intra-field variation. Differences among individual plants in the field is a common situation, associated with ineffective use of resources. It is well known that as differences among plants increase, grain yield declines exponentially, following the so-called Taylor's power law, and meaning that even a slight increase in the level of plant-to-plant variability may constitute a substantial contributor to the yield gap. Seeking the desired crop stand uniformity, the role of the variety is determinant. Let's consider two extreme types of varieties. On occasion, a number of plants of advanced growth occur at an early stage. The strong competitor will take advantage of its superiority to consume inputs insatiably at the expense of its neighbors, widening thus its superiority and inducing extra acquired inter-plant differences. Such a variety will be prone to intra-field variation. In contrast, the weak competitor will slightly take advantage of its superiority to steal inputs from its neighbors. Thus, relatively mild acquired inter-plant differences will be reduced by comparison and equality regime to optimize the use of resources. The second reason, normally part of the sown seed fails to produce plants. Thus, the occasion of missing plants in the field is another common situation. If the variety is of low plant yield efficiency, will be prone to yield loss because individuals neighboring empty hills will slightly respond and poorly compensate for the missing plants. Indicatively, in this study, the rate of yield loss parallel the rate of missing plants, a clear evidence of stagnant plant yield efficiency, and the main reason why farmers very often are obliged to resow the field. If the variety is of high plant yield efficiency, will withstand yield penalty, thanks to individuals that are highly responsive to additional inputs, and by increasing the grain yield, will succeed in a better compensation, promoting thus stability. The third reason, to counteract unpredictable stresses. The type of multi-genotypic variety may henceforth deserve more room in agriculture. In the event of a severe stress, it may be totally destructive for a monogenotypic variety if the genotype component is susceptible. Instead, in a multi-genotypic variety, a number of genotypes may collapse and others will survive. Individuals of the surviving genotypes should be highly responsive to additional inputs, the share of the missing partners, so that to succeed, the best compensation for them. Such a variety would offer a buffer against environmental diversity. The low input agriculture is important not only for poor countries. In developed countries, climate change, coupled with intensive agriculture, is leading to an ever-declining arable land. Because of soil degradation, the application of low-input agriculture is expected to widen, firstly, to keep cultivating degraded soils, and more importantly, to protect natural resources and prevent further degradation. Nevertheless, low-input agriculture is applicable only with crop spacing, and indicative is the innovative low-input system of crop intensification developed in countries like India and China, in which crop spacing is one of the 5 inviolable rules, placing special emphasis on the per plant available inputs, in other words, on improved plant yield efficiency. A key parameter to be addressed, a very important parameter, is density dependence. A complex variety by density interaction that matches the parabolic pattern. While for a stressful season, the low attainable yield can be accomplished at a low plant population density, with increasing the attainable yield in favorable agroecosystems, optimum density also increases. In other words, density dependence means that the optimum density of the same variety varies considerably across environments, and due to erratic optimum density, farmers sustain yield penalty. Considering a particular hybrid in a single location across 11 consecutive seasons, the attainable yield varied, and the same occurred for optimum density, ranging from 5 up to 10 plants per square meter. And the rhetoric but burning question arises: what the outcome would be for that dry season if farmers would establish instead 10 plants per square meter, the optimum of just the previous season, hoping to succeed the high yield levels of the previous season, and it's very common for farmers to make decisions mainly on the results of just the previous season. Instead of high yield, the result would be zero, an absolute disaster. Motivated by this study, early in 2012, I wrote this article pointing out that such a disaster is likely to happen on dry seasons due to very high populations. In fact, I was prophetic. It happened just the following summer in the main maize belt of USA, bringing corn into the stock exchange market that year. In 2018 also, record drought across Germany caused crop failures. The same can be seen in wheat. The potential yield loss of this variety would be up to 80% in a dry season if the established population would be large enough to meet the optimum of just the next more favorable season. The remedy relies on improved plant yield efficiency, essential to lower and stabilize the optimum density, and converting crops to density independence, meaning that density independent varieties could be planted at low populations as the dry season demand, but would be able to reach the attainable yield of favorable seasons as well, thanks to individual plants that are capable to take advantage of abundance in resources at the single plant level. In conclusion, crop spacing via the productive ideotype is imperative to address stability issues amid an unsustainable environment. The aforementioned risks and threats is the outcome of breeding and then stand. I'm going to present another option of breeding with the regime of nil competition, the absence of competition as an inviolable rule. In den stand, the strong competitor dominates and fictitiously becomes selectable. The productive ideotype becomes selectable only if it is widely separated to escape the obstructive influence of competition, ideally at the nil competition regime, which means that individual plants are widely spaced to prevent any plant-to-plant interference for any input, so as its plant to grow seamlessly and fully express its yielding capacity. The space input, the space share is the decisive input. It should be large enough to allow completely independent above ground and underground plant growth. In this option of breeding, three are the key characteristics: absence of competition between individual plants to facilitate identification of the productive ideotype, equal share of inputs, and comparable conditions among both the progeny sister lines and the plants of the same line, of the same sister line. According to the breeder's equation suggested by Falconer, the response to selection is expected high when high phenotypic differentiation is attained, improved plant heritability is also attained, and high selection pressure is applied. Results from a single study in which mass selection was applied under both competition and nil competition regimes are sufficiently informative that the nil competition regime than the competition can satisfy the three requirements of the breeder's equation. Nil competition maximizes phenotypic expression and differentiation. Each plant reaches maximum growth, followed by maximum differences between plants. This is reasonable. Considering two genotypes whose the ratio for their phenotypic value is 2:1, assuming that this ratio remains constant with as the density of competition weakens, the ratio remains constant, but their difference increases, reaching the maximum when competition becomes 0. And indeed, in this study, almost 8 times higher mean yield was followed by 5 times higher S-value. Nil competition optimizes heritability. Firstly, thanks to moderated environmental variance. There is a general consensus that lower densities moderate the environmental influence. And in this study, the 40% lower coefficient of variation reflects lower environmental influence on genotype expression. In addition, experiments in breeding under nil competition, honeycomb selection designs, perfectly sample the spatial heterogeneity. A standardized, instead randomized, even and systematic entry arrangement, along with implementation of main principles of other models, make the honeycomb experimental model unique to sample the spatial heterogeneity, found in this study advantages over the classical, the popular experimental designs. Let me a simple example. In the initial source material, any plant is considered for selection on the basis of the mean performance of all the plants included in a circle, with the plant lying on the center of the circle. Simulating thus the nearest neighbor adjustment method. Suppose these 7 plants are selected in the initial material, with each plant representing a separate progeny sister line. In the following experiment, any entry, any line, is evenly distributed across the entire experimental area, forming thus the most comparable conditions among these lines to decide which of them will go on the procedure. Plants of the same entry, for example, entry 1, are always surrounded by plants of the rest entries, forming the so-called complete systematic circular block, evenly distributed, and forming the most comparable condition to decide which plant of this sister line is selectable. 5 minutes? Okay, thank you. Nil competition allows high selection pressure because at the right edge of the yield distribution, plants of the productive ideotype are accumulated, in contrast to competition where plants of the competitive ideotype are found. Thus, high selection pressure can be applied seeking the productive ideotype only in the nil competition regime. And as a matter of fact, in this study, with increasing the selection pressure, a positive response to selection was found, while the reverse was true under competition. And an additional advantage, the occasion of empty hills in an experiment is very common. In dense stand, empty hills may cause bias selection because plants neighboring the empty hill gain an acquired advantage and may become by error selectable. In another option, these plants can be discarded from selection. However, by omitting them, this may cause loss of desired genotypes. Mind that with just 5% empty hills at scattered positions, at least 35% of the initially established plant should be ignored. Instead, under nil competition, the empty hill does not affect neighboring plants, so they can be considered for selection without any risk of bias. Some experiments under nil competition in lentil, in cotton at an early and late stage, in corn, maize, and soya bean. Recently, we constructed an art package for statistical analysis of the honeycomb selection designs, presented in these two papers. More information about this, someone can find in this poster outside. As a conclusion, in the second part, to meet the breeder's equation, selections should be conducted at nil competition, focusing on the productive ideotype, so as to achieve density-independent varieties and crop spacing. Two Greek scientists, eminent Greek scientists, set the basis for this new option of breeding. Papadakis was the first suggesting the single plant as evaluation unit and selection among widely spaced plants. He also suggested entry distribution across the entire experimental area as a measure against spatial heterogeneity. Professor Fasoulas perfected the method, setting the nil competition as the inviolable rule. He also developed the honeycomb selection design distinguished for systematic instead randomized arrangement. It is noteworthy that a well-known, famous wheat breeder, Australian wheat breeder, Fisher, becomes an ardent supporter of the method. For anyone who seeks for more information about this presentation, can find on this paper, published a year ago. I recently also completed an e-book on the method, hoping to find time for an English version as well. I have to say that the deeper we go, the simpler science becomes. Norbert Bolog used to say, we can do another green revolution by doing what we did before with common sense. I believe that the documentation of just presented views is a matter of common sense. Thank you very much for your attention.
Thank you. Is there any question or any comment on crop spacing and for the crop improvement? I think there is no much breeder in the hall, and unfortunately I'm not a breeder, otherwise I would ask you a good question. Okay, and thank you very much again. Dear colleagues, this is the end of the session, and I don't know the next one. So now the coffee break, and there is no session until 3 p.m.
and gentlemen. Now we will start after the tea break. The first speaker is the Hassan Berk. He will talk about the effect of different flight parameters on spraying efficiency in pesticide application with unmanned aerial vehicle in sunflower. Let's welcome Hassan Berk.
Thank you. Dear Chairman and dear guests, welcome to my presentation. My name is Hasan Berk Özyurt. I'm a research assistant at Tekirdağ Namık Kemal University. And my professor Çelen and I has been conducting some field tests about drones in spraying since 2020. Today I'm going to present our last study named Effect of Different Flight Parameters on Spraying Efficiency in Pesticide Applications with Drones in Sunflower. Everyone knows about something about the drones, and these also called unmanned aerial vehicles. They are in our lives for several years, and they are used for cargo transportation, saving lives, filming, building structures, pipe inspections, rescuing, surveying, and obviously farming. And drones in agriculture have many areas, such as crop health monitoring, geofencing, livestock management, soil and plant analysis, planting, fertilizing, and spraying. We will focus on spraying of the drones. Aerial pesticide applications have started with planes, as known as crop dusters, and helicopters. These vehicles are piloted aircrafts and commonly used in USA and South America. It was used in Turkey until 2006, but because of the health and safety risks, they were banned. And Yamaha from Japan was the first spraying UAV manufacturer in 90s. The picture below the slide shows the first unmanned crop sprayer. And as of these days, there are many drone manufacturers focused on spraying UAVs. And they are used as an alternative or substitute for conventional spraying applications like tractors, field sprays, etc. Of course, similar to every new technology, drone sprayers have so many problems. And we have 4 main problems on drone spraying. First is low uniformity. As you see on the below right side, there are dark green and lighter green lines that's caused by the low droplet distribution uniformity. And second is spray drift. Drift means movement of the droplets from the outside of target area. As you see on the upper side, the droplets generated from the UAV has to go downside, but because of the wind effect, they are going towards the wind direction. And the third one is less coverage on the leaves because of the ultra low volume applications and phytotoxicity. Can you hear me, by the way, in this distance? Can you hear my voice? Okay. And sunflower is the most important oilseed crop in Southern Europe and Black Sea region. 26 million hectares planted in the Black Sea region, and 51 million tons of sunflower seed is produced by 2021. It is also important in our country, Turkey. As 980,000 hectares of land is planted with sunflower, and 2.5 million tons of sunflower is produced in Turkey. And Thrace region, northwestern of Turkey, has the most of the production of sunflower. As I said before, sunflower is a crucial crop in Turkey, and pesticide applications in sunflower are usually carried out by conventional field sprayers. In our study, we aim to determine the droplet distribution uniformity and droplet penetration success with different parameters of drone spraying applications for sunflower. In our study, we used DJI Agras model MG1P RTK octocopter. It has 4 T-jet flat fan nozzles, and it has 10 liters of tank capacity, and its batteries have 20 minutes of flight duration. And once the field boundaries are set with the help of the RC, radio control, it flies fully autonomously. The experiments were last year on the late June. The location was Tekirdağ Viticulture Research Institute. They also have some field crops besides their orchards and vineyards. And the weather was sunny and clear. Average temperature was 32.5 degrees. Humidity was 52%. Wind speed was 1.3 meters per second. And the sunflower cultivar was Pioneer P64 LP 130. And the growth stage in that time was R6. That means, as you see on the picture below, grain formation is completed and flower drying has started. The reason why we choose that stage, because the sunflower reaches the maximum canopy density in that time. Because we wanted to also evaluate the penetration of the droplets below the middle leaves. And 60 meters plus 50 meters plot was set as a boundary, and our working width was 4 meters. And on that plot, we chose 6 individual plants, and we placed water-sensitive papers on the plants. Each plant has 4 different water-sensitive paper. We divided the plants for 4 different zones: inner flower, back of the head, middle leaves, and lower leaves. Water-sensitive papers are special yellow papers. They turn into blue when it gets wet with droplet, another moisture or something. And we can evaluate the droplets on the paper. 8 trials were conducted with the combination of 2 different altitudes. They are 1.5 meters and 2 meters from the top of the sunflower. And 2 different spray rates, 10 liters per hectare and 20 liters per hectare. And 2 different flight speeds, 11 kilometers per hour and 19 kilometers per hour. And 3 repetitions for each trials. That means total of 24 flights. After each flight, we collected the water-sensitive papers from the sunflowers, and we put them in the sealed bags. Then we scanned them with a scanner and transferred to the computer. And we evaluated some droplet analysis with the deposit scan software. In that software, this is a raw image. Then we had to convert it with 8-bit image. And then the software can detect the droplet zones. And we can have a volumetric median diameter, coverage of the surface area, total droplets, and droplet density. and the results. When we look at the volumetric median diameter, that means average diameter of the droplets. No significant differences for average volumetric median diameter between the trials. In trial 2 and 7, as you see here, the average diameter of the droplets are a bit little from fewer from the average, because they are the blue columns are lower leaves, and dark green columns are dark green is our central flower. Because of the structure of the sunflower cultivar, in that stage, the head looked towards the ground. That's why some droplets couldn't reach the inner flower zone, I mean A zone, and also the lower leaves. And when we focus on the droplet density, as you see on the graph, the yellow ones are back of head, and they have the highest deposition of the droplets, and lowest depositions are on the lower leaves. Because the sunflower has the height of 2 meters approximately, and it's so hard to reach for the droplets to reach the lower leaves. That means the penetration success is low on that drone application. And with the increasing spray rate, our deposition was increased. Between 1 and 3, trial 3 was with 20 liters per hectare, and trial 1 is 10 liters per hectare. Similar with 5 and 7. And increasing flight speed decreased the droplet deposition. And about the flight height, no correlation between the trials, but we have another success criteria for the success of the application. It's coefficient of variation. In all pesticide applications, coefficient of variation has to be below 25% in conventional sprayers. But for drone applications, any of the researchers in this area couldn't achieve that threshold. I mean, it's 25%. So, when we look at the table, the lowest coefficient of variation in number of droplets is on trial 8. So we can say that trial 8 has the best droplet distribution uniformity. And about the droplet density, we have some minimum density values for all pesticide applications. According to the table below the slide, parameters used in trial 1 and 2 will not be effective for any kind of pesticide. For other trials, a successful pesticide application can be obtained only for insecticide and pre-emergence herbicide applications. In all trials, inner flower zone and the lower leaf zone have fewer droplet deposition than the threshold value. That means 20 droplets per centimeter square. So as a conclusion, fewer droplet deposition on the lower leaves and areas facing the ground, resulting low penetration. Average diameter of droplets generated by drone is uniform for all trials. Droplet deposition is directly proportional to spray rate and inversely proportional to flight speed and altitude. Yet, the droplet deposition uniformity is not as high as the conventional spraying applications. According to our trial results, 1.5 meter altitude, 20 liters per hectare spray rate, and 19 kilometers per hour speed are the best parameters for spraying applications with UAVs in terms of both deposition rate and homogeneity. Of course, future studies should investigate the biological efficacy of the pesticides applied with UAVs. Thank you for listening to me. If you have any questions, I will be happy to answer them.
Anybody have the question?
Okay, thank you.
Thank you. Okay, our next speaker is the Gorkam Sen. The title of his presentation is Economic Analysis of 340W Solar Based Drip Irrigation System in comparison with its gasoline-based equivalent in Turkey.
Good afternoon. I am very pleased to be here today. My name is Görkem Şen. I am an assistant professor in Trak University, Department of Electronics and Automation, Uppsala Vocational School. I have a PhD degree in electrical engineering from Yıldız Technical University. Today I am going to talk about economic analysis of 340-watt solar-based drip irrigation system and comparison with its gasoline-based equivalent in Turkey. Here is the outline of my presentation. At first, I will briefly introduce electric power generation, solar energy, agricultural irrigation systems. Then I will show study area and describe methodology. After that, I will talk about cost analysis. Finally, the results of this study will be expressed. Energy is a necessity like food and water. Everything around us requires energy. All the possible gadgets and equipments need some kind of energy, especially electrical energy, to function. Electrical energy is traditionally generated at large fossil fuel-based power plants and transferred to any kind of customers. Today, the requirements of energy cannot be met fully because of reduction of fossil fuels and environmental pollution, such as global warming and greenhouse gas emissions. This energy issue is a global concern, but the current trend has been switching from fossil-based energy to renewable energy. Generally, the most known and preferred renewable energy resources are hydropower, wind, solar, but also biomass, geothermal, and wave are other renewable energy resources. Solar energy is the most abundant source of energy in the world. Photovoltaic generation is an efficient approach for using the solar energy. PV systems generate electricity from sunlight collected by solar panels. This energy can be used directly, stored in batteries, or converted to AC via inverter and used. The makeup of any PV system depends on the type of load it powers and, more importantly, whether it is connected to grid. Although the initial investment costs of solar systems are relatively high, this system amortizes their costs in a reasonable period of time. Turkey has a high solar energy potential and is situated at sunny belt of the world. Sunlight duration in Turkey varies seasonally. daily sunlight duration is almost 5 hours in winter, 7 hours in spring, and 11 hours in the summer months. Colors of the energy potential atlas of Turkey illustrates total annually average values. Potential of solar energy is directly proportionate to sunlight duration of areas, and significant amount of power could be obtained from solar energy in Turkey. Solar energy systems are constantly finding various application areas, such as solar heaters, PV systems. Solar-based agricultural irrigation is one of them. Irrigation, especially, is one of the most significant steps for the most suitable production in agriculture industry. Irrigation is identified as applying enough water to plants, crops, trees at regular interval for the healthy growth. Generally, there are two types of irrigation systems: surface irrigation and pressure irrigation. The drip irrigation system and sprinkler irrigation systems are included in the pressure irrigation system. Drip irrigation system is a micro irrigation technology that delivers a controlled amount of water and nutrients to the root area of crop or tree through a network of pipes and drip drippers. It has been demonstrated that altering the inadequate irrigation methods with drip irrigation could decrease water wasted during irrigation and raise crop water productivity. Also, smallholders can increase productivity of crop while saving water by adopting this drip irrigation. In spite of mentioned benefits, drip irrigation is not extensively adopted among smallholders. High capital costs and increased labor requirements of drip irrigation compared to the traditional irrigation methods, such as flood and furrow irrigation, are the main reasons for this situation. Çanakkale was established on both sides of the strait bearing its name and sparing the European and Asian continents in the northwest of Turkey. Çanakkale has 12 districts and one of them is Ezine. Ezine is the transition area of Marmara and Aegean regions. In this respect, the climatic features seen in two regions are reflected in Ezine. Summers are hot and dry, and winters are mild and rainy. Precipitation is usually in the form of rain. In terms of annual precipitation, the rainiest months are November, December, March, and April. Also, warmest months are July and August. Therefore, agricultural irrigation is an important requirement, especially in summer. The mentioned study is applied on approximately 3 acres of agricultural estate in Ezine. There are olive trees and various fruit trees in this agricultural estate. In addition, various vegetables such as pepper, tomatoes are grown on this agricultural estate. Before this study, agricultural irrigation needs were met by gasoline-based pump. Where the study is carried out, there is an artesian well with a depth of 33 meters in agricultural estate. Before the solar-based water pumping system is installed, the system, which consists of a hand water pump and gasoline-based pump, has been used for drip irrigation. Schematic diagram of the gasoline-based water pumping system for drip irrigation and photograph of the gasoline-based water pumping system in use is shown in these figures. By adjusting the speed of the gasoline-based pump, the amount of fresh water for irrigation per unit time can be regulated. Thus, the need for irrigation of this agricultural estate has been met over the long years. In April 2022, the solar-based irrigation system consisting of 2 solar panels, a circuit breaker for on-off control, and a submersible pump was installed to meet the irrigation needs of mentioned agricultural estate. Overall schema and photograph of the solar-based drip irrigation system in use is shown in these figures respectively. The electrical part of the proposed system includes 3 main parts. These are PV panels, DC submersible pump, and control unit respectively. Battery-free solar-based irrigation system is planned since irrigation is happened in sunny hours of the day. So installation cost of irrigation system is diminished. In the established system, there are 2 PV panels. Each PV panel's value is 12 volt, 170 watt. 12 volt, 340 watt DC sources acquired by connecting these 2 PV panels in parallel. Another part of the established system is DC submersible pump. the level of water of the artesian well is almost 6 meters under the ground, and this submersible pump is located at 30 meters under the ground. The last main unit of the proposed system is the control unit, which consists only the circuit breaker. The circuit breaker in the control unit has two main functions. The first of these is the perform on-off control. The other is the protect PVs and the submersible pump by cutting the current flow in the case of possible fault. As a result, it is determined that olive trees, various fruit trees, and various vegetables within mentioned agricultural estates are successfully irrigated with on-off controller in sunny hours of the day by the proposed system. For solar systems, cost analysis, also known as cost-benefit analysis, allows deciding whether the investment is economically worthwhile and compares the cost of implementation to its estimated total financial benefits. In this study, the following steps are followed respectively while performing the cost analysis. First, the speed adjustment of a gasoline-based pump was made for arranging the amount of water following per unit time. Thus, it is ensured that this system transfers the same amount of water with a certain amount of gasoline as the solar-based irrigation system. As a result of the adjustment, it was determined that if the irrigation is made by 1 liter of gasoline is placed in tank of the gasoline-based pump, it is equivalent to 3 hours of solar-based irrigation. In other words, after the adjustment, approximately 3 hours of solar-based irrigation is equivalent to the irrigation of gasoline-based pump with 1 liter of gasoline. This means that approximately 0.0055 liters of gasoline are used per minute for gasoline-based irrigation. Second, both the gasoline price in the area where the agriculture estate is located and solar-based irrigation times were recorded daily. Daily change of gasoline price in Ezine during the mentioned period is shown in this figure. Irrigation with solar energy started in April 2022 and continued until November 2022. The daily solar-based irrigation times in this period are shown in this figure. In the final step, cost calculation was made after the solar-based irrigation process was completed. Primarily, it was calculated how much fuel saving were daily achieved by using a solar-based irrigation system instead of a gasoline-based irrigation system. Monthly amount of saved fuel cost thanks to solar-based irrigation system is shown in this table. Then the total saved fuel cost was calculated. Last, process of depreciation was evaluated by comparing the installation cost of the solar-based irrigation system with the possible fuel cost of gasoline-based pump. At the end of the specified irrigation process, amount of saved fuel cost is calculated as 4,324 Turkish liras. The installation cost of the solar-based irrigation system is 4,174 Turkish liras. As it can be seen, there the solar-based drip irrigation system amortized this installation cost. As a result, it can be said that no irrigation cost will arise during the lifetime of solar panels and submersible pump. Conclusion, the utilization of solar-based agricultural drip irrigation system has various benefits, including less dependence on fossil fuels, lower operating costs, and decreased greenhouse gas emissions. Solar-based irrigation systems was installed and used in 2022. The solar-based irrigation system amortized the initial investment costs within the mentioned period. As a result, it was confirmed that the energy needs in the irrigation duration for agricultural estates can be met from solar energy. The energy need can be met by adjusting the system capacity according to the size of the agricultural estates. Generally, this study emphasized the potential of solar powers to promote sustainable agriculture and decrease greenhouse gas emissions in the agriculture sector. Thank you for listening.
Thank you. Any questions from the audience? Thank you.
Thank you.
Okay, our next speaker is the Nilgun Dogan. I don't know how to pronounce that one. Sorry for that one. And the title of his presentation is a journal evaluation on the market price effect of geo-labeled products in Turkey.
Dear Chairman and dear colleagues, hello to everyone. My name is Nilgün Doğan. I'm joining this conference from Gümüşhane University, Aydın Doğan Vocational School. And today I have two presentations. The first one is a general evaluation on the market price effect of geo-labeled products in Turkey. This is the content of my study. Firstly, I will give a brief explanation about local food products and why they have been so important recently. And also, I will talk about the GIs products, geographical indication food products, and what it represents. After that, I will give the aim of this research and which material and method we used in this study. After that, from the material we used, I'll share the results and conclusion. So you see the general titles here for the general knowledge. Human beings' relationships with food products has recently undergone a transformation recent years. Food supplied from the local region where it was lived until the 19th century, while basic foodstuffs were included in people's daily consumption, consumption patterns have changed with globalization. This transformation has reduced the consumption of local food products. However, the production of large quantities of food with a long shelf life by using intensive inputs has started new searches in consumer demands. The fact that issues such as healthy life, negative effects of production on the environment, biodiversity, sustainability, agroecological production, and circular economy have become the agenda necessitated the revision of production process and the local production. And geographical indication is a quality label that shows and guarantees the source of the product, its characteristics, and the connection between the characteristics of the product and the geographical area. With this label, it is ensured that products that have gained a certain reputation, depending on their quality, traditionality, raw materials obtained from the local area, and local qualities. So far, 1,438 local products have been registered with GI in Turkey with the name of origin or the sign of origin. Currently, 13 geographical indications have been registered in European Union. To figure out the value of the GIs, it is important to look at market size and price premiums. In this respect, the issue of what appropriate marketing strategies for GI gains importance. At the same time, it can be said that studies on the use of GI indications as a tool, agri-food products to enter international markets have become popular. So what is the aim of this research? The aim of this study to consolidate GI-labeled food products registration within the framework of pulses group, fruit vegetable pickle group, crispy pastry dessert group, cheese group, sausage salami red meat group. In the meantime, the market price effect of GI-labeled products has been examined. So what material we used? Internet search on the related websites was done to see actual prices of the GI-labeled food products. In order to obtain comparable prices with GI and non-GI products, online shopping websites were visited. First of all, we gathered data on GI-labeled pulses group, fruit vegetable pickle group, cheese group, sausage salami, and their closest substitute. When we come to the results, the first title is Market Size of Geographically Indicated Products in Turkey. Turkey is located in a geography that has hosted many civilizations with its 12,000 years of history. It has thousands of local products. 40% of the 734 geographical indications whose applications process is still in progress are owned by the chambers or exchanges. Only 13 geographical indications of Turkey are registered in European Union, but if these local values cannot be promoted and marketed, they will not be worth anything if they are not brought into the economy. This study, based on the market price of GI-labeled products considering e-commerce, the number of GI-labeled food products current in Turkish food market is very limited. GI-labeled food products available in the big franchise supermarkets in the big cities. And the supply of these products is not permanent, and they are not generally available to shoppers and are part of the non-GI products. Therefore, it was more suitable and reliable to search the market prices of the labeled food products on online shopping websites. The traditional trade method is now leaving its place to e-commerce with the change of technology and trade perception. With the right software, firms or companies started to save both money and time in this way. It seems that e-commerce and e-export are growing very rapidly in Turkey, also in the world. Looking at the figures after the pandemic, it is seen that e-commerce has turned into a necessity rather than a choice. It's a fact that Turkey has a very serious advantage and potential in the field of local products. As a result, companies or firms accelerate their e-commerce process and increase the marketing of featured products such as GI-labeled products. In the research, you see on the slide the selected of the GI-labeled food products price premiums in Turkey were studied to get an overview. In order to get real market prices data, we look at different web pages of big stores operating in Turkey. Supermarket websites, local food products websites, GI-labeled products websites can be given as an example. The most popular GI labeled food products were chosen, as you see on the slide. When the GI labeled products were chosen, a substitute food product was considered with almost with the same feature. In case where the GI labeled food product has some very original features and no other food products had similar characteristics, no substitute products has been included and that GI labeled food product wasn't presented in this table. To calculate the price premiums of the selected food products, the market prices of GI and non-GI labeled products were provided from the related websites. Our investigation was accomplished in e-shopping stores in Turkey, and according to this table, there is an impressive difference in the price premium for GI labeled food products. Overall, the average premium was around sausage, salami, red meat group had 10.08%. Pulses group had 36%. Fruit, vegetable, pickles group 44%. Crispy pastry dessert group had nearly 54%. And the highest was in cheese group with the nearly 80%. It can be seen from this table that while in Antep dry eggplant from fruit vegetable pickles group, there is no difference in the price premium for GI labeled and non-GI labeled. As you see, Diyarbakır knitting cheese, Gümüşhane köme, Gümüşhane pestil, and Taşköprü garlic have a higher price premium with 163%, 119 and 100 respectively, while Rize Village Roaster has a lower premium for 0.2%. Kelkit dry beans, Kastamonu acorn flour, Amasya marble apple, Safranbolu Turkish delight, and Maraş tarhana crispy had similar price premiums interval. According to food products groups in this research, packet or processed products, mainly pulses group and pestil köme, are not represented too much in the market, so the price margin between GI labeled and non-GI labeled is higher. In addition, vegetables, fruit, fresh meat do not appear either. It should be mentioned that although local food stores play a key role, they are not acting of the whole food retail market in Turkey. With the GI labeled food market size and price premium, it can be luckily forecasted that if a GI labeled food products market grows on food varieties, less price sensitive customers may have a higher portion and price premium of GI labeled food products. Hence, supermarkets, local stores, hypermarkets, etc. gain importance apart from the online web shops. When we come to the conclusion, price premiums of selected food products have been found to explain the efficiency of these products in the local food market. These results presented that GI labels are impressive differentiation tools in the local markets, although their relevance changes across the products. For example, GI labeling is the main differentiation for the fruit vegetable pickles group, Amasya marble apple, Taşköprü garlic, Gümüşhane pestil and köme, and for the cheeses group, but it is also low relevance for red meat group and for the dried vegetable group. In terms of these results, some strategic inferences may be derived considering the price premiums. First of all, sellers or producers can benefit of the strength of GI labeling, particularly when they are associated with the positive label image. Retail sector should take the advantages of an e-commerce. Thank you for listening.
Any questions from the audience?
I have another one.
Yes.
Our second presentation is on contract farming in buckwheat cultivation. This is the content. You can see. Oh, sorry. I'll give the brief introduction about agricultural production in Turkey and then aim of the research. When we come to the general knowledge, why agricultural production is so important, especially in our country. Agricultural production is one of Turkey's economic sectors, having about 24 million hectares of the farmland and employing nearly 3 million farmers. A fundamental view is that the country population carries on to rise while the farming remains below expectation. For example, the World Bank reveals that agriculture, which accounted for about 25% of the gross domestic product of some developing countries, is so important to economic growth. On the other hand, in Turkey, it is contributing only 7% of the country's gross domestic product. Turkish Republic Ministry of Agriculture and Forestry reports that the livelihood of almost all of the population living in undeveloped areas, for example, in rural areas, is agriculture. Therefore, the farming in the economy of the countries and creating new alternative livelihood is very important. Alternative crop production is an important advantage for a country like Turkey with a wide variety of climatic conditions. Finally, when we have a look at the research product, buckwheat is not related to cereals such as wheat, rice, and barley. It is one of the main alternative product in the crop production pattern in the world and is an important food item due to its component. Buckwheat production has become one of the most developed crop production, and it is produced in many countries of the world and has begun to take its place in international trade, but it is not commercially cultivated in Turkey yet. To promote alternative crop production in rural areas, firms or buyers can be encouraged to form collaboration with the farmers based on agreements. The farmer makes decisions about what to produce, how much, and which inputs to use in non-contract farming. In this case, it will be possible for the capital to dominate in agricultural only if the production decisions are not taken by the farmers. Linking smallholder farmers to market with the contract farming is also one solution to overcome high levels of poverty in many underdeveloped areas. The aim of this research examined the perceived benefits accruable by the farmers in buckwheat contract farming. The data in this study has been provided from face-to-face interviews that conducted from June to July 2021 in districts of Gümüşhane province. Due to the limited number of buckwheat farmers in Gümüşhane province, no sampling was made in the research area. As a qualitative work with basic on only 30 farmers is presented by solely focusing on contract farming. there are also no farmers served by the traditional and other forms of buyers in the study area. There is only one buyer who is an entrepreneur. So survey questions have been designed considering 30 farmers who are engaged to contract farming and this buyer. To give a clear picture of the perception of buckwheat farmers on the accruable benefits of contract farming, a 5-point Likert scale was used. You see the results of this study and undertitles. The first one is descriptive characteristics of the farmers. The majority of the farmers' age changes between 51 above. On the other hand, 36.7 of the participants' age varies between 41 and 50 years. This result shows us that the contract farmers are still in their effectual and productive ages. This means the farmers might be risk takers and enthusiastic in the sustainability of the contract model. This table also indicates that the years spent in education are 5 to 8 years, and this value corresponds secondary school in Turkey. With this, majority of the farmers are high school or university graduates. As mentioned earlier, farmers only produce buckwheat with contract farming model. Unfortunately, there are no buckwheat farmers served by traditional or other mechanisms of buyers in the research area. Therefore, no comparative analysis can be established. The full count sample from this study has only 30 farmers who are linked to contract farming. The remaining farmers are producing their crops apart from the buckwheat with the traditional method, which is non-contract farming. It is seen that the farmers' production patterns are mainly wheat, barley, oat, corn, and alfalfa. Considering the prices received by the farmers, it is understood the highest price per kilogram belongs to dry beans and buckwheat. It is among the results that the unit sales prices of the products such as corn, wheat, barley, and alfalfa, which are included in the traditional production pattern, are much lower. According to this finding, it is extremely important to increase the income of the farmers by going out of the traditional production pattern and directing the farmers to crop products with higher economic returns. In this respect, it is necessary to conduct studies to increase the cultivation area of buckwheat as an alternative product and to increase the production amount. The orientation to alternative products like buckwheat in agriculture is not easy for farmers due to traditional production habits. Generally, the transition of farmers to alternative products is realized through contract farming models with the initiative of private firms or entrepreneurs. Buckwheat production with the contract farming model in Kelkit, Köse, Şiran districts of Gümüşhane province started in 2018 under a private firm. The contract farming experience, as you see, in buckwheat cultivation changes between from 1 to 3 years and covers an average nearly 2 years. Contract buyers generally supply growers with inputs to use in production under predefined terms, such as pesticides and fertilizers. However, in contrast to widespread production inputs according to agreement between the farmer and the firm, the buyer only supplies limited inputs in this research. Inputs that the buyer provides to the farmers are generally limited to seeds. To compare the production amount for the buckwheat in the study area, both 2019 and 2020 were considered in this study. As it's seen from this table, the total amount of buckwheat production in 2019 was 32,785 kilogram, and it was only 70 kilogram in 2020. As nearly 77% of the buckwheat farmers who are engaged in contract farming model in 2019, this rate decreased to 40% in 2020. Knowing how the farmers evaluate the contract farming in terms of production and marketing is considered important, especially for the adoption of farmers to alternative agricultural products such as buckwheat. For this purpose, the perceptions of the farmers about the contract buckwheat farming model were examined. A 5-point Likert scale was used for the responses of the farmers to the propositions are shown in this table. According to results, the interviewed farmers strongly agree with the propositions such as the buyer's compliance with the commitments to purchase the entire product, the market guarantee, the buyer's compliance with the contract terms, the purchase of the buckwheat at the agreed price, and timely payment. These results indicate that for the promotion of new crops like buckwheat, market guarantee, timely payment, price are very important for the local farmers to participate in contract farming model. This also translates to higher buckwheat income at the farm level, because farmers are of the view that they need financial support to buy inputs like seed and harvester or tractor services to enable high yield. The contract farmers reported that they agreed with the proposition contract farming is more reliable than the traditional one at a moderate level. So therefore, working with the contract buyer can be an adventure for the local small farmers. So analyzing the internal dynamics in the current agricultural production system is very important, and also technical consultancy should be given to the farmer in the process from planting to harvest. Also, from the local authorities, agricultural credits or grants can be supplied for the small farmers in the research area. Thank you very much for your patience. If you have any question, I can have.
Any questions from the audience? Okay, I have a question.
Yeah.
Is the government of Turkey providing any subsidy or incentive to the farmers regarding the buckwheat production?
For the buckwheat production?
Yes.
Unfortunately not. There is only one entrepreneur who supplies only seed. So it's not common yet for the government local authorities to give any grant. But as far as I know, for the entrepreneurship, the government gave some grants.
Okay. And what are the terms and conditions regarding the contract farming?
Sorry?
Terms and condition. Agreement. What sort of agreement is that one with the contract farming?
Between the buyer
Yes.
and the farmers.
Is there
The buyer supplies the seed.
Okay.
And also some, in harvesting time, the entrepreneur supplies some tractor services.
Okay.
It is limited for the farmers.
Okay. Thank you.
Thank you. That's all.
That's all. Thank you. Okay, the next presenter is the Gorkham Sen. He's going to present his research work on the design and implementation of an off-grid solar-based semi-automatic drip irrigation system for olive groves in Çanakkale.
Hi again. Let me introduce myself once again for newcomers. My name is Görkem Şen. I am an assistant professor in Trak University, Department of Electronics and Automation, Ipsala Vocational School. I have a PhD degree in electrical engineering from Yıldız Technical University. Now I am going to talk about design and implementation of off-grid solar-based semi-automatic drip irrigation system for olive groves in Çanakkale. Here is outline of my presentation. At first, I will briefly introduce electric power generation, agricultural irrigation system, irrigation needs of olive trees. Then I will show study area and describe proposed solar-based irrigation system. Finally, I will talk about the results of this study. Energy consumption is increasing at a rate of almost 1% per year in the world. This rate is around 5% per year in developing countries. Briefly, the energy demand is highlighting day by day. However, fossil fuels cannot meet this energy demand because of various reasons. The main reasons for this are the reduction of fossil fuels and environmental pollution, such as global warming and greenhouse gas emissions. Expanding the use of renewable energy resources is a sustainable approach aimed at both reducing the burden on fossil-based energy resources and reducing environmental pollution around the world. Due to scarcity of fossil-based energy resources, all countries around the world have sought new energy resources such as renewable and nuclear. Nowadays, the current trend has been switching from fossil-based energy resources to renewable energy resources. Renewable energy resources includes many types of energy resources such as hydropower, solar, wind, biomass, geothermal, tidal, and wave. Solar energy is the cleanest and most abundant renewable energy resource available on the Earth. Solar energy is the most notable, free, available, and clean energy for the environment among all renewable energy resources. Photovoltaic generation is an efficient approach for using the solar energy. PV systems generate electricity from sunlight collected by solar panels. This energy can be used directly, stored in batteries, or converted to AC via inverter and used. The makeup of any PV system depends on the type of load it powers and, more importantly, whether it is connected to the grid. So PV systems have a remarkable position in the generation of electricity worldwide. Sunlight duration in Turkey seasonally change, and daily sunlight duration is nearly 5 hours in winter, 7 hours in spring, and 11 hours in summer months. Therefore, Turkey has a remarkable solar energy potential, and this potential is shown in this figure. Solar energy systems are consistently finding various application areas. Solar-based agricultural irrigation is one of them. Solar-based agricultural irrigation systems are one of the most featured applications of solar energy systems. Nowadays, gasoline-based water pumping systems or electric water pumping systems are mostly used in agricultural irrigation. Electrical water pumping systems, which are extensively seen on operation are single and multi-stage centrifugal pumps, surface pumps, and submersible pumps. Solar water pumping systems are required in rural areas due to inability of consumers to connect to the utility grid. Thus, off-grid solar-based agriculture irrigation systems are required in recent years. Various files, such as especially rural areas, desert press, and certain metropolitan areas. Considering change of climate, the increasing population and requirements of food, it is seen that the importance of fresh water for human life increases day by day. Consequently, more effective and more efficient use of fresh water use in agriculture becomes a necessity. The concept of irrigation refers to how the water is transferred to the root area of the tree or crop. There are two types of irrigation system: surface irrigation and pressure irrigation. The drip irrigation system and sprinkler irrigation system are included in the pressure irrigation system. Drip irrigation system is a micro irrigation technology. This system has a network structure consisting of pipes and drippers. With this system, sufficient amount of water and nutrients are provided to root zone of trees or crops in a controlled way. It has been demonstrated that preferring drip irrigation method over other integrated surface irrigation methods can cut down on the water wasted during irrigation and enhance the water productivity of the group. However, smallholders do not generally prefer the drip irrigation method today. High capital costs and increased labor requirements of drip irrigation method compared to traditional irrigation methods such as flood and furrow irrigation are seen as the main reasons for this situation. But if smallholders adopt these drip irrigation systems, they can save water and increase crop yields. Olive trees make a great economic contribution to countries such as food industries, olive oil industries, soap industries, wood productions. Olive tree is known as a traditional rain-fed fruit tree and one of the most drought-resistant fruit trees. Olive trees are one of the few sustainable trees available for farmers in a arid agricultural asset all over the world. Although olive trees are resistant to water stress, if it is desired to obtain high yields or increase the amount and quality of olive oil every year, it is necessary to give importance to agricultural irrigation. In spite of the fact that olive tree is a drought-resistant species, some phenological stages such as the flowering, fruit set, and oil accumulation periods are the most sensitive to water stress conditions. The methods used in olive irrigation are as follows: surface, drip, and subsurface irrigation. Çanakkale, which is in the borders of the Marmara region, is a province of Turkey located in the northwest part of the country. Çanakkale has land in both the Asian continent and the European continent. Çanakkale has 12 districts, and the provincial borders of Edirne, Tekirdağ, and Balıkesir surround this province. This study is carried out in Ezine district of Çanakkale. Ezine is the transition zone of the Marmara and Aegean regions. Hence, the climatic characteristics seen in these regions are reflected in Ezine. Winters are mild and rainy. Precipitation is generally in form of rain. According to meteorological observations, the rainiest months are December, November, March, and April. On the other hand, summers are hot and dry. The hottest months are July and August. For this reason, agricultural irrigation is a significant need, especially in summers. Olive tree is a species that exhibits selectivity in point of the climate characteristics. Çanakkale and its nearby districts are among the significant regions of olive and olive oil production in Turkey. Especially Ezine is one of the places where olives are grown extensively in Çanakkale. In this study, off-grid semi-automatic drip irrigation of almost 3 acres olive grove in Ezine has been realized with a system consisting of solar panels. Overall schema of the system and photograph of the solar water pumping system in use is shown in these figures respectively. The electrical part of the proposed system consists of 3 main parts. These are PV panels, DC submersible pump, and control unit. Solar irrigation system is planned without battery group, since irrigation is programmed between 9 a.m. And 6 p.m. During the day. Thus, installation cost of the system is reduced. In the present system, there are 2 PV panels. Each PV panel's value is 12 volt and 170 watt. By connecting these 2 PV panels in parallel, 12 volt, 340 watt DC source is obtained. Characteristics of PV panel are expressed in this table. There is an artesian well with a depth of 33 meters in the olive grove where the study is carried out. The water level is about 6 meters below the ground. DC submersible pump is located at 13 meters below the ground, and it has been observed that the DC submersible pump works successfully. Characteristics of DC submersible pump in use are shown in this table. The last main unit of the proposed system is the control unit, which consists of the circuit breaker, the digital timer, and the Paco switch. The duties of the elements in control unit are as follows. The circuit breaker in the control unit has 2 main functions. The first of these is to ensure that the system is completely shut down. In other words, the current from the PV panels is completely cut off. The other duty of the circuit breaker is to protect the whole system by cutting the current flow in a case of a possible fault. 12 volt digital timer in the control unit allows 12 volt DC submersible pump to operate between 9 a.m. and 6 p.m. every day of the week with a total of 16 different programs. Also, adjustments of the timer are not related since the timer has an internal rechargeable battery. Paco switch enables the user to stop irrigation to perform manual irrigation or to perform timed irrigation. If selector of Paco switch is in the position 0, the irrigation system does not work. If selector of Paco switch is in the position 1, the user can irrigate manually. If selector of Paco switch is in the position 2, automatic irrigation can be performed according to the setting on the timer. In addition, the control unit gains a semi-automatic structure, as above selection can be made with the Paco switch. As a result, it is determined that 40 olive trees within olive grove are successfully irrigated every day of the week between 9 a.m. and 6 p.m. both manually and time adjusted by the proposed system. Conclusion. One of the significant renewable energy resource is solar energy. Solar energy can be used in various areas, and one of these is agricultural irrigation. In this study, the off-grid solar-based semi-automatic drip irrigation system was designed and installed for olive grove irrigation in Ezine district of Çanakkale. With installed the semi-automatic system, irrigation can be done both manually and time adjusted. The present study is a suitable solution that can be used to meet other agricultural irrigation needs besides olive groves irrigation. According to the size of the agricultural lands, the need of energy can be met by adjusting the system capacity. Solar-based drip irrigation systems are a significant alternative because these systems are more economical and eco-friendly, especially in rural areas where electricity facilities are not sufficient. Therefore, it will be beneficial to introduce these solar-based irrigation systems in order to develop both our farmers and our country economically and agriculturally. Thank you for listening.
Thank you. Any questions from the audience? No question? That's good. Thank you.
Thank you.
Okay, we have a next speaker. Gulsak Keklek. I don't know how to pronounce that one. Sorry for that one. I don't know who is this one. And that presenter is going to deliver this speech on the mathematical and statistical interpretation of parameters used in some bioinformatics databases and software tools. Welcome.
Okay. That's okay. Hi everyone. I'm coming from Çukurova University. Today I will talk about mathematical and statistical interpretation of parameters used in some bioinformatic databases and software tools. I will talk about BLAST and BLAST parameters at first, general parameters and scoring parameters. General parameters, parameters in this section specify the search sensitivity, the max target sequences sets, the maximum databases sequences with max plus saves for a given query. The checked short queries checkbox allows BLAST to automatically optimize settings for queries 30 bases, residues, or shorter. The expect threshold filters out matches that are less significant with the expect value above the setting. The word size sets the size of the initial seed match. Smaller settings are more sensitive. The maximum matches in a query range limits the match saved to a given region of a query, such as from repeats, so match to another region of the query can be reported. The default settings of 0 means no limit. Scoring parameters. Parameters here also affect the search sensitivity. The match-mismatch score specifies the reward assigned to an exact match and penalty assigned to the mismatch. The gap cost field specifies how gaps introduced in the alignment should be penalized. For MegaBLAST, the default is linear with no penalty for opening a gap, while extending a gap assumes a linear penalty proportional to the length of the gap. For both parameters, no default settings can be selected using the pull-down menu. We will look about BLAST N, MegaBLAST. This contains MegaBLAST and BLAST N. MegaBLAST for sequence identification, intra-species comparison, and is intended for comparing a carry to closely related sequences and works best if the target percent identity is 95% or more, but is very fast. And the other option is this context MegaBLAST for cross-species comparison, searching with coding sequences, and it uses an initial seed that ignores some bases, allowing mismatches, and is intended for cross-species comparisons. BLAST N for searching with shorter carries, cross-species comparison, and it is slow, but allows a word size down to 7 bases. And you can see on the screen general parameters and scoring parameters. Those are max target sequences, short carries, expected threshold, and word size, max match in a carry range, and scoring parameters composed of match-mismatch scores and gap costs. BLAST P simply compares a protein carry to a protein database. PCI BLAST allows the user to build a position-specific scoring matrix. Using the results of the first BLAST P run, PHI BLAST performs the search but limits alignments to those that match a pattern in the carry. Delta BLAST constructs a PSSM using the results of a conserved domain database search and searches a sequence database. BLAST X for identifying potential protein products encoded by a nucleotide carry, and you can see on the screen the general parameters, scoring parameters, and some filters and masking parameters. T-BLAST and search translated nucleotide databases using gap protein carry, and also you can see on the screen the general parameters, scoring parameters, and filters and masking. T-BLAST X search translated nucleotide databases using a translated nucleotide carrier. And you can see on the screen again general parameters composed of maximum target sequences, expect threshold, word size, max match in a carry range. And also scoring parameters composed of matrix is generally Blossom 62. And there is also filters and masking. String, in this shape, it means that your proteins have more interactions among themselves than what would be expected for a random set of proteins of the same size and degree distribution drawn from the genome. Such an enrichment indicates that the proteins are at least partly biologically connected as a group. And you can see the maximum and the minimum scores on screen. Parameters of the string database: number of nodes, number of edges, average node degree, average local clustering coefficient, expected number of edges, PPI, that's protein-protein interaction, enrichment p-value. And there is also clustering parameters, and you can see on the screen some clustering options, and K-means clustering and MCL clustering. Also, K-means clustering network is clustered to a specified number of clusters, and H-bit being clusters. Also, MCL clustering network is clustered to a specified MCL inflation parameter. XPazi ProdParam. ProdParam is a tool that enables that calculation of various physical and chemical parameters for a given protein stored in SwissProt or Tremble, or for a protein sequence entered by the user. The calculated parameters are molecular weight, theoretical isoelectric of point, amino acid composition, atomic composition, extinction coefficients, estimated half-life, instability index, aliphatic index, and grand average of hydrophaticity, that's GRAVI. Theoretical PI, this is isoelectric of point. When the theoretical PI value takes a value between 0 and 7, the protein shows acidic properties, and when it takes a value between 7 and 14, it shows basic properties. Extinction coefficients, the extinction coefficients indicates how much light a protein absorbs at a given wavelength. It's useful to have an estimation of this coefficient to follow a protein in a spectrophotometer when purifying it. Instability index provides an estimate of the stability of your protein in a test tube. Values below 40% indicate the stability of proteins. Aliphatic index of a protein is defined as a relative volume occupied by the aliphatic side chains as a alanine, valine, isoleucine, and leucine. It can be considered as a positive factor for increased thermostability of globular proteins. Aliphatic index values greater than 71 indicate that all enzymes have a thermostable structure. Grand mean of hydrophaticity. The GRAVI value for a peptide or protein is calculated as the sum of the hydropathy values of all amino acids divided by the number of residues in the sequence. XPASI-Prot scale. Prot scale carrier screen provides access to various features such as alpha helix, beta fold, total beta strand, and amino acid composition. In the Prot scale database, there are more than 50 predefined scales entered from the literature, some of them molecular weight, polarity, alpha helix, beta turn, amino acid composition, and beta sheet, total beta strand, and parallel beta strand. UniProt is the world's leading source of high-quality, comprehensive, and freely accessible protein sequence and functional information. While the presence of a protein provides information about the presence of a protein, although it doesn't provide information about the accuracy or precision of the sequences displayed. The sequence may differ from genomic sequences, especially for sequences derived from gene model predictions. There are 5 types of evidence for the presence of a protein in UniProt knowledge base. Experimental evidence at protein level, experimental evidence at transcript level, protein inferred from homology, protein predicted, and protein uncertain. AlphaFold, the shade of green indicates expected distance error in angstroms. The color at X, Y corresponds to the expected distance error in residue X's position when the prediction and true structure are aligned on residue Y. Dark green is good, and it means that low error. Light green is bad, and it means that high error. Modbase is a database of comparative protein structure models calculated by our modeling pipeline, ModPipe, and it contains theoretically calculated models which may contain significant errors and not experimentally determined structures. In addition to the protein structure models, Modbase contains information about putative ligand binding sites, SMP annotation, and protein-protein interactions. And you can see on the screen some parameters about mode base, target region, protein length, template, protein data bank code, template region, sequence identity, e-value, etc. Cobalt computes a multiple protein sequence alignment using conserved domain and local sequence similarity information. And you can see on the screen alignment parameters, constraint parameters, carry clustering parameters, and alignment parameters composed of gap penalties and gap penalties. Constraint parameters composed of RPC blast, constraint e-value, and conserved columns. And also carry clustering parameters composed of carry clustering parameters, word size, maximum cluster distance, and alphabet. SDD. The conserved domain database is a resource for the annotation of functional units in proteins. Its collection of the domain models includes a set created by NCBI, which utilizes 3D structure to provide insights into sequence, structure, function relationships. And MEGA-X. MEGA, this is the last one. MEGA is an integrated tool for conducting automatic and manual sequence alignment, inferring phylogenetic trees, mining web-based databases, estimating rates of molecular. And you can see on the sequence some of parameters. Thank you for listening.
Thank you. Any questions from the audience?
Okay.
Thank you.
You're welcome.
Our next speaker is Usman Pato. The topic of his presentation is probiotic properties of lactobacillus fermentation and Pedococcus pentosaurus encapsulated with or without hydrogel cellulose microfiber from oil palm leaves.
Bismillah. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. I am Osman Pato from Universitas Riau, Indonesia. It's very near to Singapore and Malaysia. I want to talk about probiotic properties of Lactobacillus fermentum and Pedococcus pentosaceus encapsulated with or without hydrogel of cellulose microfiber from oil palm leaves. This is the outline of my talk, including background, objective, materials and method, result and discussion, conclusion and acknowledgement. As we know that Indonesia is the largest palm oil producing country in the world with an area of 16.38 million hectares and a CPO production of 49 million tons in 2023. And Riau province, where I live, is one of the largest palm oil production centers in Indonesia with an area of 3.46 million hectares in 2023. So with the existence of the very large oil palm plantation, the potential for palm oil waste is also very abundant, especially oil palm solid waste, includes empty fruit bunches, fiber, fruit shells, trunk, frond, and oil palm leaves. And this picture shows that this is the picture of oil palm, and about 10% of this plant produce 10% oils, and the rest, 90%, is biomass, including oil palm leaves, oil palm trunk, oil palm branches, and so on. And this waste can be used as a bioenergy or a biocomposite and so on. Especially for oil palm leaves, this is obtained from regular what we call it regular cleaning of oil palm trees for old and unproductive leaves, and also to prevent nesting sites of pests and places of growth of disease-causing microbes in plants. So the potential for farm front and leaf waste reaches about 40 to 50 fronts per tree per year. It is according to the finding of Hassan and Ishida in 1992. So the number of farm trees in 1 hectare may vary by country. For example, in Indonesia, the number ranges from 114 to 116, while in Malaysia, it can reach until 170 to 200 sticks. Now, as we know that Indonesia is the largest palm oil land area, as I mentioned before, the oil palm leaf waste is very abundant. Now, one product of the oil palm leaves is cellulose microfibers. This CMF is currently widely used in the health, medicine, filtration, and sensor industry. For example, in the biomedical sector, CMF can be processed into CMF hydrogel as a fashion wound cover and drug and health product coating. And especially in the food industry, CMF has the potential to be used as an encapsulation material for probiotics and bioactive compounds. Let me talk a little about probiotic. Probiotics are live microorganisms that can provide health benefits when consumed in adequate amounts. The probiotics are often associated with various mechanisms that contribute to their functionality, including some probiotic properties that I can explain later. And in the previous study, we found that cellulose microfiber hydrogel from oil palm leaves was able to maintain the high viability, acid and bile resistance of Lactobacillus fermentum inaceae B1295 during storage for 28 days at room temperature and cold temperature. So the objective of the study were to evaluate the safety of cellulose microfiber hydrogel from oil palm leaves as an capsulan for raw material for Lactobacillus fermentum and Phytococcus pentosaceus. And the second, to assay the probiotic properties of Lactobacillus fermentum and Phytococcus pentosaceus encapsulated with or without cellulose microfiber hydrogel from oil palm leaves. This is the material and method. The research were conducted experimentally by evaluating the safety and probiotic properties of Lactobacillus fermentum and Phytococcus pentosaceus encapsulated with CMF hydrogel from oil palm leaves. And the material used in this study was palm oil leaves that obtained from one of oil palm plantation in Riau province in Indonesia. And this is parameter of SERPs. The first one is safety assay of free and encapsulated probiotic cells conducted by using the method of Tan et al. 2013. And the second parameter was the antioxidant properties of the probiotics, including HRS activity and scavenging ability of DPPH radicals, according to Sehata et al. 2019. The third one is autoaggregation conducted by using a method of Malik et al. 2013, co-aggregation conducted by using method of Kumar et al. And hydrophobicity conducted by using method of Singh et al. 2017. The data obtained was, for example, especially on the data on safety evaluation were analyzed descriptively, and the data on antioxidant activity, autoaggregation, co-aggregation, and hydrophobicity were statistically analyzed using analysis of variance using IBM SPSS version 23 software. And if F count more than F table, it was continued with Duncan multiple range test at 5% level. And this is the result. Probiotics use a microorganism that can be used as a probiotic must be safe. So in this study, we evaluate the hemolytic activity, production of cytolysin, production of gelatinase, and production of bioamines. And the data is shown in this table. And we can see that two lactic acid bacteria used in the study, Lactobacillus fermentum and Pseudococcus pentoseus, were safe because the two bacteria did not produce hemolytic activity, did not produce cytolysin, gelatinase, and biogenic amines. And also, one of the probiotic properties that can be made by probiotic is ability to produce antioxidant activity. And the result is shown in this table. We can see here that both free cell and encapsulated cell could produce, could scavenge the DPPH radicals. And we see here that based on IC50 number, the highest scavenging ability was found in bacteria, especially Lactobacillus fermentum encapsulated with cellulose microfiber hydrogel from oil palm leaves. And also we analyzed another antioxidant called HRS activity, and we see here that also Lactobacillus fermentum encapsulated with CMF hydrogel from oil palm oil palm leaves show the highest HRC activities. So another probiotic properties that should be met by probiotic is auto-aggregation. Auto-aggregation refers to the ability of probiotic to aggregate or clump together. So auto-aggregation can be beneficial as it allows the probiotic bacteria to adhere to surface of the gastrointestinal tract more effectively, so they can enhance their colonization and persistence in the gut. And the result can be seen here in the table. We see that the free cell and also encapsulated cell both could aggregate, but the highest one was found in the free cell of Lactobacillus fermentum, encapsulated, without encapsulated with CMF hydrogel from oil palm leaves. Another properties is co-aggregation. Co-aggregation is a phenomenon where probiotic can bind or adhere to other microorganisms, including potentially harmful organisms. This interaction can help probiotic compete with and inhibit the growth of pathogenic bacteria in the gut. This contributing to a healthier microbial balance in our gut. And you can see in this table that both lactic acid bacteria with or without encapsulated with cellulose microfiber hydrogel from oil palm leaves can bind with other lactic acid bacteria or other pathogenic bacteria. In this study, we use pathogenic bacteria where E. coli and S. aureus. Yeah. And then we can see that the highest co-aggregation was found in Lactobacillus fermentum encapsulated with CMF hydrogel from oil palm leaves with Pedrococcus pentosaceus. Another probiotic properties is hydrophobicity. Hydrophobicity refers to the affinity of probiotic bacteria for hydrophobic, water repellent surfaces. Probiotic bacteria with certain level of hydrophobicity can adhere more strongly to the mucous lining of the gut, which can enhance the ability to colonize and interact with the host intestinal cells. And the result shown in this table, we can see that both free cell and encapsulated cell have hydrophobicity, but the highest one was found in Lactobacillus Pedrococcus pentosaceus encapsulated with CMF hydrogel from oil palm leaves. So this is the conclusion. Lactobacillus fermentum inaceae B1295 and Pedrococcus pentosaceus strain 2397 without encapsulation or encapsulated with CMFH from oil palm leaves do not produce hymolation activity and do not produce cytolysis, gelatinase, biogenic amines. So these two lactic acid bacteria are safe to use as probiotics. Lactobacillus fermentum and Pedrococcus pentosaceus cells without encapsulation or encapsulation with CMFH oil palm leaves produce relatively strong DPPH activity. Lactobacillus fermentum encapsulated with hydrogel of oil palm leaves produce the most HRS activity, and compared to free cell and closed cells in these two lactic acid bacteria, Lactobacillus fermentum and Pseudococcus pentosacchaeus showed higher level of co-aggregation with harmful bacteria. In this case, we use S. aureus and E. coli. And the last conclusion, free cells of Lactobacillus fermentum in ACC B1295 show the highest hydrophobicity score. So this study was funded by the Ministry of Education, Culture, Research and Technology of Republic of Indonesia. So we appreciate it for that. And this is our research team, including for lecturer and for undergraduate student. Thank you for your attention.
Thank you. Any questions from the audience? Okay, thank you, Professor.
Okay, thank you very much.
Okay, the next presenter is the Sheherban Sheikh. The topic of his presentation is fish stem cell technology in aquaculture.
First of all, I would like to thank you, organization committee, and particularly to Dr. Yalçın Kaya. And today, I'm going to talk about new technologies that which are being used for fish stem cells in aquaculture. Contents of my talk will include germ stem cell transplantation in aquaculture, stem cell-based fish meat production, and gene transfer in aquaculture by editing germ stem cells. Okay, well, aquaculture is the world's largest growing sector currently. However, because of the global warming and pollution, and as a result of global warming and ocean acidification, it's expected that global aquaculture production will be decreased by 2050. However, it's really difficult to measure to measure the effects of global warming in aquaculture production. But there are some comprehensive studies that suggesting that aquaculture production will be decreased in coming years. And therefore, in order to continue aquaculture production for sustainability of aquaculture production, new technologies, cutting-edge technologies I mean, approach cutting-edge technologies should be important. I mean, we should have an open approach to cutting-edge technologies. Let's look at these technologies. First, I'm going to define the stem cells, and then I will carry on other topics. Fish stem, there is no international definitions, I mean, international standardization for fish stem cell definitions, but basically there are two major points. One, classification is based on their potency, I mean differential potential, and the other classification is based on their origin. My friend Fatma Günaydın, at the meantime, my colleagues, we designed this slide together, and as you can see in this slide, when eggs and sperm are combined together, they produce a zygote, and zygotes, I mean, after production of zygote, these cells start to divide it by mitosis. And these cells are embryonic stem cells. When we take only one cells from embryonic stem cells, they can differentiate and they can create a whole fish. I mean, these cells can differentiate to nerve cells, germ cells, intestinal cells, liver, and then they have the power, they have the differential potential to create an organism. In this slide, they have the power to create a whole fish. Once when they differentiated to different cell types and produce an adult or matured fish, they have no power anymore to differentiate into different kind of cell types. And then, I mean, what I am trying to say, in the matured fish, in the adult fish, also have got stem cells, but these cells only can differentiate into special cell types. Okay. In the above picture, you are seeing the spermatogonial stem cells that were isolated from a fish species. In the right picture, you are seeing an oasis that previously isolated and then differentiated, grown into an oocyte cells. Primordial germ cells are only embryological cells that can carry genetic information from one generation to the next. Therefore, they are extremely important cells. Because as I just said, they are the only cells in all organisms that can carry genetic information from one generation to the next. In the picture, you are seeing primordial germ cells, which they have got a nucleus inside the cells and a slightly stained cytoplasm around them. And then these cells are, not get used to use this pointer anyway. On the right of the slide, you are seeing primordial germ cells, which are, when you look at them under the microscope, they have a movement, amoeboid movement, and they move into the gonadal enlagia or gonocyte. These gonads has not been differentiated into male or female yet. I mean, they have got no primordial germ cells inside them. Therefore, we define them as gonadal enlagia or gonocyst. And these cells are, they have an amoeboid movement and they move into gonadal enlagia, and then they start to multiply by mitosis and then differentiate into a male or a female. What is the power for their differentiation into, what defines them to differentiate into a male or a female is their microenvironment. In the picture, you are seeing differentiation stage cells. I'm not going to give a detail about them. Anyway, in this picture, in this imagination, you are seeing the transplantation of primordial germ cells into embryo and adult fish and larvae. There are basically three methods that you can transplant primordial germ cells into an organism. In the first one, first you isolate primordial germ cells and then you culture them and then you transfer them into embryo at the mid-blastula stage in the picture A. But mid-blastula stage can change, the duration of mid-blastula stage can change from fish species to the other, from one species to the other. And this duration is also time, mid-blastula stage duration and time is also, temperature is also effect on this duration. There are two, one fish species and the other one is temperature. But in this technique, you have to wait until these larvae get matured and produce eggs and sperm. In the second method, you inject primordial germ cells into a fish larvae. One may be asked, why are we transplanting in the larvae? Because larvae has not developed immune system yet, and therefore has no the capacity to reject the primordial germ cells. That's why we are we are transplanting these cells in the very early stages to embryo or at the blastula stage or to the larvae. But just after 3-4 days fertilization. As I said before, this duration changes from species to fish species. In the last method, primordial germ cells can be injected also adult fish or matured fish. But what I would you like to explain in here, this adult fish previously has been sterilized by triploidy or by hybridization technique. And although these techniques are not, sometimes, triploidy itself is very difficult to apply, and the other reason, triploidy, when you apply triploidy in a fish species, there is very high mortality rate. And then this is the third method for transplantation of fish germ cells. Now, why it's important to transfer primordial germ cells from one species to the next species? I would like to explain here for giving an example that which is an example that is widely given, widely given example. That's why I choose particularly to give these two fish species. Bluefin tuna is a very large fish species weighing 500 kilograms, and it's completely difficult to maintain in hatchery conditions because it's a huge fish, and it is maturation age is 5 years, and sometimes more than 5 years. And therefore, as I said, it's quite difficult to maintain and to look after in the hatchery conditions and to feed it. Fish feeds are quite expensive, and therefore, it's not economic to keep it. It's very expensive to keep it in the hatchery conditions. when you take germ cells, primordial germ cells from bluefin tuna, and then transplanted to chub mackerel species, you can produce bluefin tuna gametes in chub mackerel species. These two fish species completely are, these two fish species are related to each other. They are from the same family. However, chub mackerel weighs only 5 grams, 500 or 300 grams, maximum 500 grams. What I am trying to say is chub mackerel, it's easy, it's cheap, it's, not difficult to handle, and it's mature quite early. For maturation stage, you have to wait only 1 year, not 5 years. Therefore, you are using here chub mackerel as a broodstock, as a broodstock mother, and you are producing bluefin tuna gametes, sperm and eggs. That's why this is one of the application areas. The reason is to improve fish production in short time, in an inexpensive way. Yes, and the other application areas is to prevent some fish species which are extinct or going to be extinct in the future. I don't know whether have you ever heard about cryopreservation, but I think you have. It is almost like last four decades, 40 years, it has been 40 years that fish sperms are being preserved by cryopreservation in the liquid nitrogen. And it is easy to preserve sperm. However, it is difficult to preserve eggs because eggs have got lipids and protein inside them. And embryo, in case of embryo is also very difficult to keep it, to preserve it in liquid nitrogen. However, it is very easy to keep for years primordial germ cells or spermatogonial or gonial stem cells in the liquid nitrogen. You can keep them for years because comparatively they have no lipids and protein in them, very little. Therefore, when you compare them, you can apply this technique. You can keep primordial germ cells in 4 years. In here, first primordial germ cells are isolated from an extincting species or going to be extinct in the future. First, you isolate these cells and then you culture them. After culturing on them, you can cryopreserve them in liquid nitrogen, and then you can by xenotransplantation, you can transplant in a different or in the same family fish species, and then you obtain sperm and eggs from, you use it as a surrogate mother. And then you obtain sperm and eggs and regenerate the missing species of fish or any other animal species as well. You can protect them in this way. Now, second subject of my talk is stem cell-based fish meat production. Stem cell-based fish meat production, maybe it will very much surprise you that in the world currently, as I checked from the recent articles, currently there are 100 companies trying to produce fish stems, stem cell-based meat production. And 30 of them are only interested in fish stem cell-based meat production. Some others, again, there is no international terminology about cell-based meat production. Some others call it cellular meat, some others cell culture meat, engineering meat, factory grown meat, in vitro meat, fake meat, clean meat, meat, synthetic meat, anyway. But Holmond, 2031, he made a comprehensive study. He uses large data and suggested to use cell-based seafood to label fish cell-based meat production. I have given some examples of companies from all around the world, and one company from China, Celix, founded in 2020. I think Celix China, yes, it was founded in 2020. And this company announced that they are going to produce 1% of the all world meat production by cell culture. This company has already been founded. In my country also, in my country there is a team that they are working from Ankara University, but they are only working on to evaluate a serum. They are not working sea-based feed production. They are just working on terrestrial animal-based meat production. Here, I try to give a summary of how this procedure is going. First, you have to take cells from the fish. But these cells are, there is more than one type of muscle cells in the fish. You have to first, after taking these cells from the fish, you have to separate them using biomarkers and then culture them. And then when you culture them, you have to grow them in bioreactors. But there is no, the perfect reactor should be available. If it's not available, then the results sometimes is not successful. And then these cells pass through a 3D printer and then give a shape, and that is ready for consumption by the humans. In the world, in Singapore is the first country that allowed the stem cell-based meat product for safe consumption and commercial sale. And the United States of America is the second country which allowed stem cell-based products as safe consumption and sale. I took this data from the internet, and I have also given the, maybe not here, but perhaps in the next slide. Singapore and United States of America, these are the countries at the moment that allow this meat production for safe consumption and sale. in their countries. There are some very important issues, of course, regarding to this technology and others as well. First of all, the muscle tissue, as I explained before, has multiple cell types, and it's very important to isolate the specific cell types. And cell lines for crustacean is not available yet, and cell lines for some species are very well developed for some fish species, but not for crustacean. And traditional self-culture method relies on completely serum. Maybe in the future, but it's difficult for sustainability. I mean, there is always no serum available. This is one of the challenges that needs to be overcome by the sector. Meat structure is mostly dependent on the scaffold as well. Markers are important to separate muscle cells and progenitor cells from each other. And consumers and customers may resist, and this is definitely in some countries, this is normal. I mean, they will be resistant not to use and not to buy this product. And currently extremely expensive. Finally, cell-based meat should meet the desired texture, color, and appearance in natural meat. I mean, there should be no differences between natural meat and cell-based cultured fish meat. Gene transfer in aquaculture by editing germ stem cells. Yeah, sorry for this. Okay. These two scientists has got the Nobel Prize in 2020 because they developed the CRISPR-Cas9 technology. I'm just going to give the information on this slide, how it is application, how it's applied to germ cell culture and surrogate mother technology. First, you isolate germ cells, and then you edited these germ cells with CRISPR-Cas9 technique. I mean, you give these germ cells, for example, let's say that the gene which is very resistant to fish diseases and is growing very fast, and then you, after addition of these germ cells by CRISPR-Cas9 method, you transfer them to surrogate brood fish. Again, this surrogate brood fish previously has been sterilized. I mean, they have no endogenous germ stem cells. And then you obtained sperm and eggs which are edited from donor primordial germ cells. And then you edited donor derived oil-spring pool, and in this way you produced many fish larvae, and at the end, fish. And Japan is the first country in the world that allowed to gene editing, and I think the fish species was sable fish, and they used this technology, genome edited fish was available in Japan, and Japan has allowed for human consumption. But this fish species was one, and I think it was called sable fish, as I remember it. In my review, it existed, but I couldn't remember now. Okay. Now, regarding to these three technologies, all of them aims to produce meat. I mean, to increase aquaculture products. Their aim is this, but of course there are major challenges, major problems that needs to be overcome. And these challenges, these problems these techniques are not easy to apply. For each of them, for primordial germ cells transplantation, for genome editing, and for fish stem cell-based meat production, the techniques, the methodology has not been developed perfectly. And therefore, and the other major obstacles and problems, and these meats maybe rejected by the consumers. That is other major problems needs to be overcome. But whatever I say, in the next decade, meat produced by these technologies will be on the market. In some countries, maybe not in all countries around the world. Even now, currently, as I said before, Singapore and Japan and United States of America have given some permissions to projects. Thank you so much for listening. Well, I was very tired, and my presentation was not really good. But if if you have any questions, please do ask. I would like to answer it. Now I'm relaxed. I can answer better.
Thank you. Any questions from the audience? So
I was expecting so many questions. Really?
You already
because the subject is...
Okay, no question is the good question.
Well, no questions.
Thank you.
Thank you again for giving your valuable time.
Thank you. So the next and the last presenter is the Fatma Gun. I don't know. I have pronounced it correctly or incorrectly, and she's going to present. She's going to deliver the talk on the zebrafish as a model for fish bacterial infections.
Dear Chairman, dear colleagues, I would like to thank you, organizing committee. My name is Fatma Gün Aydın. I am from Çukurova University. I work at the Biotechnology Center as an associated professor. My special area is fish disease. Welcome to my presentation. I am going to first introduce the subject that I am going to talk about: introduction, fish bacterial disease pathogenesis, immunomodulators, bacterial disease treatment, conclusion. Zebrafish has some outstanding features among model organisms used to study certain biological processes. These features are rapid development with short life cycle, external fertilization, and transparency of embryos, mating diploid stage, small adult size, ready availability, and reasonable cost of maintenance. As you see, zebrafish develop rapidly from a one-cell zygote that sits on top of large yolk cell. Gastrulation begins approximately 6 hours post-fertilization, hatching at 4 days as a free-swimming larva. Zebrafish reach sexual maturity around 3 months of age and can live for up to 5 years. As you see, representative events separating different stages are shown. Adult zebrafish, the anatomy of zebrafish embryo at 2 days after fertilization. A diagram of zebrafish anatomy, a representative image of transparent 6 DPF larva captured with bright field microscopy. Aquaculture is fastest growing food producing sector in the world. Furthermore, aquaculture production is expected to grow from the current 46% to 53% by 2030. However, fish disease incidence cause high losses in production. Particularly bacterial infection leads to significant wide-scale mortality in economically important culture fish species. This review aims to provide latest information on the bacterial infection in fish where zebrafish have been used as a model organism in order to increase fish health and welfare in farms. Investigation on immunomodulators, bacterial diseases treatment, and pathogenesis description will be assessed. Fish bacterial diseases, pathogenesis, the capacity of bacteria to cause diseases in aquaculture, fish species reflects its relative pathogenicity. Pathogenesis alludes both to the mechanism of the infection and to the mechanism by which disease develops. Now, I would like to show you latest studies on zebrafish as model organism species. Wetrat and Kate have investigated to evaluate the pathogenesis of the infections. Immunomodulators are agents that change an animal's immune system so that it can work more efficient and effectively. They included treatments that increase an animal's immune response. They treat various diseases, including fish bacterial disease. Inactivated probiotics are called paraprobiotics, and their microbial metabolites are called postbiotics. Vaccination is considered pivotal as it is one of the main approaches to control bacterial fish diseases. Currently, there are over 26 vaccines approved for a variety of fish species. Bottom line, vaccination are ideal method for prevention of some bacterial fish diseases in the aquaculture sector. Nevertheless, research related to the development of an effective and commercial vaccine is needed. Probiotics. The use of probiotics is promising alternative approach for the control of infection agents and treatment of disease in aquaculture. Live or inactivated probiotics confers some valuable benefits to the host. These benefits can be listed as improved disease resistance, enhanced immune responses, producing antimicrobial substances, improving competition for nutrition, competing with pathogen to the binding sites, and therefore protection host against pathogens. Nevertheless, there are some disadvantages in administration of probiotics in aquaculture. Inactivated probiotics are called paraprobiotics, and their microbial metabolites are called postbiotics. Therefore, recently, paraprobiotics and postbiotics administration has been suggested by many researchers. Now, I would like to give some example in order to increasing immunological response fish. Kui et al. Have investigated immune responses in zebrafish, for example. Bacterial disease treatment. Although antibiotic treatment is a rapid and effective method for treating and preventing bacterial fish infections, the frequent use of antibiotic agents has allowed the development of drug-resistant strains of bacteria. In recent years, phage therapy has gained increasing attention in terms of the biological control of bacterial infection in marine and freshwater aquaculture due to the emergence of antibiotic resistance pathogen on farms. Another alternative to antibiotic is using medicinal plants as therapeutic in aquaculture sector. The use of medicinal plants in aquaculture has been widely studied, implying their great potential to enhance growth, immunity, resistance against various bacterial infections, easy preparation, fair price, safe and environmentally. Some gram-negative bacterial behaviors are regulated by a cell density dependent mechanism. Some gram-negative bacterial behaviors are regulated by a cell density dependent mechanism known as quorum sensing, which relies on communication between bacterial cells using signaling molecules known as autoinducers. Quorum quenching is the inhibition of quorum sensing using chemical or enzymes to block communication, and as a result, behaviors regulated by quorum sensing. Latest studies on the bacterial fish disease treatment by using zebrafish bimodel are given in Table 3. Leanto et al. Have investigated the efficacy of phages effects. In view of the threat posed by endogenesis and incorrect use of antimicrobial agents that can lead to the development of bacterial fish disease, we review a number of alternatives to antimicrobial in aquaculture. These include pathogenesis description in modulatory vaccination strategies, phage therapy, aquarium quenching, probiotics, parabiotics, antibiotics, and medicine plant therapy. In the review, particularly recent studies on zebrafish were included. Zebrafish models have received widespread attention for investigation and evaluation of the pathogenesis of bacterial fish disease. It will contribute to the enhancing bacterial fish disease resistance in the aquatic environment. This model alternative to other economically important large-body marine and freshwater fish species for investigation of fish disease, which are essential for improving the sustainability of the aquaculture sector. As it is given in the present review, zebrafish, it is a perfect model organism for investigation of bacterial fish disease. Thank you for listening.
Thank you. Any questions from the audience? Thank you.
Thank you.
So, in this session, we have the 9 presentations. And the presenters, they spoke about different aspects regarding the agriculture sector, from the food science, from the engineering, and from the fish biology sector. Thank you, all of those one.